All right. I'm assuming that it is actually on like Twitch is showing stuff.
Yeah.
Okay.
Yeah.
I mean, I don't necessarily trust OBS all that much to tell me the truth about what's going on. Let's see. Last time where we left off, it was somewhat working. We had lights going, and then it all just, oof, that was loud. Then it all just shut off and died, but the drum stayed spun up. And so I actually found all of the power supply schematics. I think I'm gonna have to fire up my other laptop so I don't risk crashing the stream by alt-tabbing. I tried that this Wednesday. We were streaming and I hit alt-tab and it like crashed the stream hard. Apparently my laptop does not like streaming and then alt-tabbing to multitask.
I may have a laptop I can lend you, but I don't know that I'll give it to you.
I've got another laptop here that I can just use to like dig through stuff. It's a pretty good laptop.
Well, this is a Ryzen 8-core Zephyrus G14 with an RTX 2060 mobile.
Good Lord.
So it should be a lot more capable of handling your stream.
Yeah, well, eventually, I'm just going to upgrade to a proper dedicated streaming PC because I would like to get multiple cameras going on and stuff like that. I think it would be better to just like build a rig that's dedicated to streaming. Put it on like a little roll around wheels or something.
Yeah. Now that I could possibly give you because I do have a number of PCs and some pretty decent specs on some. I'll reach out to you, DM.
Yeah, I've got some pretty decent desktop stuff. I just use a laptop in here because I don't have any space to like get a desktop permanently set up. Yeah, hopefully before the end of the year, we'll get the ball rolling on a bigger studio, and then that'll change everything, right? Because once we get a bigger studio, then we can build all sorts of dedicated stuff in there. The hope would be to like almost triple the floor space that I've got in here. I mean, assuming that YouTube ever wants to play nice and like show my videos again.
Yeah,
YouTube, my view count halved overnight. And then like, you ask, apparently this didn't happen to everybody. It just happened to like, half of the users on YouTube, half of the creators on YouTube. And so if you ask anybody that this didn't happen to, their response is just like, oh, just get good, noob. And then you ask the people that it happened to, and they're like, I don't know what's going on.
Well, one of the ones that was impacted was Linus Tech Tips, and they're about one of the YouTube channels out there. So
yeah. So Linus Tech Tips was hit pretty hard. They took I actually looked at some of their videos and like took an average of views from before August 13th and after August 13th, and they took an average 400,000 view drop on their videos. So, yeah, that's a pretty noticeable hit, right? That's not just get good, noob, right?
Oh, definitely. And Jeff Geerling also noticed it and published an article on it on his blog as well. I think last week's WAN show on Linus Tech Tips, they were talking about it and had thrown up some graphs, and they got a very good sized team, so they've got someone that specializes in looking into their analytics.
Yeah. I did notice, so one of the things that Linus was echoing, or the Linus was saying, was that it seems like the number of likes has not dropped. So their like to view ratio has gone way up, because they're getting the same number of likes per video, but their views have, plummeted, right? And so, they're not really sure what that means, but it means that there's not a proportional drop-off in revenue to match the drop-off in views. And I'm not seeing that as much as they are. I definitely took a drop-off in revenue, but my likes have stayed pretty close to the same. So I think it's just changing up the quality of views. I don't know. But the truth is that if your video is not being pushed out there, you're not going to grow. So for somebody that's got, 10 million subscribers like Linus Tech Tips, that's not as concerning. But it is a little more concerning if it's if you're small. I'm trying to find the I don't have the documentation for the Litten here, so I'm trying to find it.
Hello, finally here.
Hello, welcome.
Yeah, for the views, I'm thinking they changed the definition of a view. So, like, people just scrolling through the YouTube, their auto-playings, like, if they were counting those as views, they were never gonna like, dislike, or even participate in monetization.
Yeah, I think there's a bit of that. I think they also may have kind of gone to war against fake views. Fake views is maybe not right, like bot farms or AI scraping and stuff like that from multiple places around the world. So I think there might be a bit of that going on as well. All right, there we go. I've got the reference manual open now. So if we need it, it's here. I forget which pages the actual power supply schematics are shown on, but they're down there somewhere.
My bet is the 5-volt one.
Is the stream being stupid for anyone else?
It
now
did.
it seems to have recovered for me.
Yeah, it was frozen for a little bit with the little swirl, and then it woke back up.
It's still within the first 15 minutes. It's gonna crash or oh wow, we've dropped 1900 frames. That is impressive. But it didn't crash out completely, so it is what it is.
So impressive, yeah.
Yeah. All right. Well, I suppose the first thing we should do is just check the fuses.
Yeah. Would the would that kill everything if the 5-volt rail died?
I bet it's the 5-volt rail because it's not the 18-volt rail, or we would have lost the lights immediately.
We did lose the lights immediately.
No, we didn't. They all flashed on at the same time and then dimmed.
Okay.
So I'm betting the 5-volt rail dropped, the 18-volt rail is fine, and we just saw what they have a RC filter integrator, they described it as. So we just saw that go slightly crazy for 2 seconds.
All right. Well, we got a slow blow here on F6.
If they documented their fuse, it would be useful.
Yeah. Well, no, they do.
Actually,
if they do.
Oh, yeah.
If you look in that one's good. 0.6 ohms. Yeah, in the manual, so in the technical reference manual, they do have schematics for the power supply. They're not all sequential. They're kind of spread out, which is a super annoying.
The whole the whole document is like that.
Well, that fuse is now bad. I was trying to look. I don't know if you guys can see that.
It's not supposed to do that.
It's not a slinky. It's
yeah.
fuse.
I mean, it's a mechanical fuse, but it wasn't supposed to be one.
Yeah. Well, that's slightly alarming. Well, that fuse, I don't know if that fuse was bad and I just destroyed it by trying to pull it out of the plastic cap here. But we know for a fact that it's bad now. Let's see here. This one says nothing on it. So that I'm gonna have to look that one up. That's fuse F6.
F6.
That was a slow blow fuse, but
Yeah.
Oh, that one's one of the mains.
This one is fine.
It's a 3 amp.
3 amp slow blow. I can do something about that. I think it's an awfully long fuse though. I don't know if I've got one that long.
they aren't standard AGC length.
It might be. I'm just not very good at judging the length of glass fuses. I do have a 3 amp slow blow, but it is notably shorter. That's a bit of a problem. Look at this. I don't know if you can see the height difference there.
The stream finally caught
Yeah.
up. Oh yeah, those are longer.
Yeah, I'm not really sure how we're going to get around that.
A nail and just jam it in the slot.
Well, yeah, but I mean, it's not going to make connection. It's
No, I mean,
We-
nail as an extension.
I hope you're not proposing a 30 amp fuse or more.
it might actually. Well, it is 3 amps, right? You said it was 3 amps. 3 amp
Yeah.
slow blow, right?
It's not described as slow blow in
It's definitely a
note.
slow blow. Considering that I just ripped out the spring on the inside, I've never seen a fast blow look springy. That might actually work. Hang on.
No, I was commenting on if you put an iron nail in that, you just turn your 3 amp to a 30 or 300 amp.
Yeah, I could also put a 22 long rifle shell in there and have a audio visual alert.
Oh yeah, that Mythbusters.
Yeah, I think you need a 22 Magnum for the length.
Yeah.
I was just thinking the 3 amp fuse with a tinfoil spacer.
All right. Okay, so I crammed something in there and it feels like it's making connection. It might not be fantastic, but we're going to find out. Let's go over to this side because we got 4 more fuses over here.
Yeah. Okay, where the heck is the 5-volt rail?
So the 5-volt rail is actually derived off of the 28 volt or something like that. So if we lost the 28, we would have also lost the 5. And it's just like a separate regulator.
Not seeing 28. There's 35 and 18 and 13.
It shows 1.8 ohms. I mean, it should be showing less than that, but could just be
Oh,
0.7.
I need to do more of these, copying these pages into my OneNote.
0.6. 0.7. So why are you showing 1.8?
It's a negative 24 volt. Is that what you meant?
Ooh, you don't want to come out, do you? All right. Well, okay. So I've got 3 fuses. They all show about 0.7 ohms, but then I've got one that shows like 2 ohms. It's probably fine, but I'm not super confident in it. So I'm going to pop it out and see what it says. If I can get it out without destroying it. Looks all right.
Oh, so that's T3. Been looking at these diagrams.
So what does F6 do?
F6 is power to everything inside the computer before the transformer.
Okay, so if F6 is bad, like if my connection's not making good connection, we'll know it.
Yeah. Yeah.
Okay.
Oddly enough, it might have been the one that blew up because the drum motor is parallel to that.
Oh, so if the drum motor's separate from F6, the drum would keep spinning.
Yep.
This one shows 2 ohms, man. I'm not a fan of that.
Which holder was that?
Not clearly marked holder. It's one of the little fuses on the actual board. Not one of the big boys. It's on the, I don't know, is there a diagram in the manual?
Unlikely, but
You never know. I was like on the right page, and then I touched the laptop, and it speared off about 150 pages away.
might have landed on the right one.
Yeah, so there's 4 fuses on the main board there. F1, F2, F3, F4 that are for each of the individual voltage rails. Plus 35, plus 18, plus 13, minus 24.
Yep.
It's the half amp one. So F1
Okay.
for
Plus
plus 35. Yeah, it's measuring
F1.
2 ohms across it, which it's probably just corroded a little bit.
I don't know because it's like a bit ridiculous. They have loads for the plus 35, and they're like 144 ohms, 115 or 86 for low. Like 2 ohms plus that doesn't change much.
Yeah. Well, I've got a brand new half ohm or half amp that's the exact same size, so I'm just going to swap it out. Make life easy. Get a fresh fuse in there. All right.
I need to find the 5-volt rail because.
Okay. Well, in that case,
I might be right here. Oh no, that's warm up.
let's flip the switch, see if lights come on. If they don't, we'll check the rails on the front, and then go from there. And I'll see if I can get the camera to not blow out with light. There we go.
Oddly enough, I've never seen the fan spin in that device.
Oh, it spins.
Oh, good.
Yeah. I mean, not that it matters too much because we got the whole thing wide open right now. All right. Let's see if F6 was the problem. Well, F6 was a problem because now I'm not even getting... Oh, helps if I turn the power strip on. There we go. Works better if you turn the power strip on. And we are gonna... I'm gonna steal the stool and move the chair here to have that. Okay. Let's try this again. Well, the drum's spinning up. No lights still.
Not good.
Yeah. We got a problem somewhere. Time to find it.
Did they not fuse the 5-volt rail?
All right. Let's check some voltages here. See, plus 13 is at 0. Minus 24 is at 0. Plus 18 is at 0. Plus
Okay.
35 is at 0. So all of my voltage rails are at 0.
I would bet on F6.
Yeah. All right, let me find that spot in the manual here. There it is.
Page 344.
Yeah, I got it. I just need to. I'm trying to figure out how to like. Trying to figure out how to rotate it. Also trying to figure out how to get out of full screen. There we go. Boy, Linux's PDF viewer is not great.
Which
I've been
PDF viewer is that?
Yeah, can you guys hear that squealing?
Yeah.
That's the drum motor. The drum bearings. They are unhappy. So the drum spins, which says F6 is fine, because that's...
No. F6 is separate.
I'm seeing two F6s, one on the primary, one on for the motor.
No, the whole other board is T3.
The whole other board.
The other diagram, the one that has all the rails, is the T3 block into the diagram that has the power pin. The drum's around it. It's getting power from 4-5, like the notes.
I swear, this is the worst PDF viewer. Like, the built-in PDF viewer in Linux is just terrible. It can't rotate.
Which desktop environment is it?
Mint?
Yeah, I'm not sure. Is that Cinnamon? I'm not sure. What?
Yeah.
That's what I was thinking. Yeah.
Yeah, it cannot rotate the page.
I use Ocular, which actually works quite well on Linux. I'll post the name in the chat.
Yeah, I've been using Sumatra just on Windows because I was getting a bit pissed off with Adobe.
Yeah, Adobe's terrible, but
Yeah.
all right. So T3, F6 is the fuse that goes to T3, which is the board that has all of the rails.
Yes.
Maybe? Oh, yeah, I see that. No, T3 is a transformer.
Oh, okay, that's how they're describing it. Yeah.
Yeah. T3 is a transformer. So we're if all of our rails are dead, that says that the T3 transformer is not catching AC, which you're right. I think kind of limits us to the drum.
The drum, the fan, and the power relay that turns on the drum and the fan.
Yeah, so if the fan spins and the drum spins, that's got to be... So F5 has to be good because our power button works. F7 has got to be good because without F7, the drum would not spin.
Same for F5, because your power on switch works.
So we've got a jumper A and jumper B. Well, I was worried that I had broken the jumper because I had broken the jumper and I've kind of got it pushed into place now, hoping that it would work. But if the jumper were broken, that wouldn't go either.
Yeah, you wouldn't have the relay, so you wouldn't have the drum motor.
Yeah. So the question is are we not making good connection on F6, or did we blow the fuse like immediately when we tried to plug it in, power it on here? Should probably unplug it.
The weird thing I'm seeing is like F6 3 amps in parenthesis 1.6. It's like
1.6 is for 240 volt.
oh, makes sense. Yeah, because there's a note for okay, yep. That makes a lot of sense.
Yeah, they list it up and they say that's for the 240 volt stuff.
In the other diagram, they just put parenthesis. It's like, parenthesis for what?
All right, so we didn't immediately explode the fuse. We just aren't making proper connection because my fuse is too short. Although it certainly felt like we were making proper connection.
If the fuse hasn't been blown, it hasn't been exposed to 3 amps yet. It needs more power.
Well, it's a slow blow, so even if it did get 3 amps, it wouldn't explode. The trick is I'm trying to figure out how to make it fit. So I need to pick up how much space here? Considerably more space than I was trying to pick up.
Damn, I just realized it shouldn't have been broken before.
What do you mean?
Because we didn't lose 18-volt rails.
I think we did, man. I think you're because you're looking at the, like, when I was sitting in front of it, it went. Like, nothing staggered. It just was gone. Boom. The whole thing just shut.
That's the advantage of video playback. You can look at it in real time.
No, that should fit. I need like a little slug or something to put in here and make good connection.
Like lead BBs?
Yeah, something.
That'd be nuts.
All right. You guys get to
How
watch
about
me.
the end of the old fuse?
Yeah, the end of the old fuse is currently in there.
So that's what was the solution.
Yeah, so the fuses have this weird thing going on where they have like little lips. I'm showing the camera, but there's probably like a 30-second delay here or whatnot. They've got these like little lips that stick out that hook on the inside and hold the fuse in place. So it's good that the other end of the fuse is still stuck in my cap here. But because I've got this big hollow cavity, this thing just kind of pushes up against it and doesn't make good connection. So I need like a little slug that I can slip into this hollow cavity that'll push on the fuse, affirmatively and make a good connection here.
You're sure that's not to hold the whole cap into the machine?
It
is.
The holder? It is, but it's also part of the fuse.
Oh, Lord.
Yeah. Because, like, here's the fuse that got pulled off of it. And it's just like, you can see it's just exposed glass that goes into that metal part, and there's no other metal part. So the fuses themselves either were sold with this plastic cap or intentionally had the little wings to clip it into the actual machine. And they're way long. They're crazy long.
Is there a spring inside that cap?
No. Well, I mean, there was some spring stuff, but it's all destroyed now because the whole thing came apart.
No, I mean inside the cap itself that has the little wings, the red piece.
There isn't, but I can put a
not
spring
what's
in
your
it.
hand. Yeah, that right there. Is there
No,
a
yeah.
spring inside there?
There isn't, but I think I can put a spring in it. That's a good idea. I like your
Because
idea.
if you look at the Bowman fuses, they're the same type and they have a spring inside there.
Okay. That's a good idea. I never would have thought of using a spring. We got a whole box of springs out here. I may cut out. I'm pretty far from the computer at this point.
Maybe he can't hear us, but we can still.
I can hear you guys just fine, but the
good.
headphones and the microphone are different. So they have different ranges, I'm imagining.
And that's what I was testing.
Did you guys find the part of the manual where it says pretty much ignore the power supply section because it can change?
That sounds typical.
I'm not joking. It's in there.
All right. I have a spring. I have a little spring sitting in there. So we're going to try that. Hopefully that will give us good enough connection.
I hope we won't end up with a... Oh, no, that should carry 3 amps.
Yeah.
That is a specific type of fuse with an integral fuse and holder knob.
Yeah, that's a terrible, terrible, terrible idea.
And I found a link to a 10 amp one on Amazon.
All right.
Slightly overrage, but...
It's a bus, man.
Yeah, it does actually say Busman on it. Okay, that's in place. I don't know how I would confirm that we're making good connection. I'm half tempted to cut the wires and put an actual real fuse holder in.
DigiKey seems to have all the types, all the sizes.
All right, let's see if that made a difference. Still no lights.
That is a Busman GLR, Golf Lima Romeo series fuse, and there's a bunch of them on Amazon. Different ratings.
Yeah, we're still at 0 volts for every single voltage rail.
Is there a way we could test the secondary directly?
Yeah, we need to check something.
Or the primary post diffuse, but...
Yeah, I think what we need to do is we need to slide the power supply out and actually just check connections, make sure that everything's actually connected up. Because the schematic shows it as, you know, just lines, but there could very well be a wire in there somewhere that broke. And it's making it look like F6 went bad, but F6 didn't actually go bad. Big screwdriver.
Yeah, because...
You lost everything coming out of T2, right?
T3.
T3, I'm sorry.
Yeah. Pretty much we have no DC voltage at all, but we still have fan and drum. So, you know, since we have fan and drum, that says that we clearly still have AC coming into the system.
Right.
All right, I am going to need...
And we have AC pretty close also. Because, like, at least schematic-wise, the drum's right over T3.
Well, physically they're in wildly different places, but
Yeah.
which is why I'm thinking let's just pull the power supply and start checking physical connections here. This feels a lot like maybe we had a connector go bad somewhere, and we're not getting AC over to T3.
Yeah, I mean, if it was a cap, there'd be usually more excitement involved, but and I can't think of anything else that would just fail and take everything else. Even a transformer would let you know it's unhappy.
Yeah, maybe we'll see if something looks scorched on it.
Like the old PCs, the old 12-volt drive connectors, the scorched Molex.
You know, I never scorched a Molex.
A lot of people had meltdowns in what was it, Molex to SATA adapter.
Really? And that feels like a really common adapter for it to just have a lot of meltdowns going on.
I really don't like the price of these fuels.
Well, that's why we're not going to buy one. That's why we're using a spring. But clearly, there's something else going on here.
There's a meme called Molex to SATA, lose all your data. It was the type of connector. The SATA side, because it was all embedded in the plastic, the cheaply made ones would roast.
All right.
That fuse was worth 10x its value.
Yeah. If it turns out that it's like a connection problem on the fuse that we're fighting, I think I might just cut the wires and put a real fuse holder in there. All right. It's always power supply problems.
Ain't that so?
Let's get you guys a little closer.
Well, at least with this one being ferromagnetic, it's not going to be as bad as the 1144 power supply, hopefully.
Oh man, the 1144 power supply. Like, oh, I have a great idea. Let's put 300 volts DC on a flex PCB that we run straight on top so you can accidentally touch it.
Caution tape?
Yeah. The caution tape was, if you have any power supply problems, call the deck guys.
They'll bring the 10-foot pole?
No, they just swap it out because uptime is the most important thing on the planet. Swap it out and go give it to the engineers to deal with. All right. I'm not seeing anything looking scorched on top. I'm still slightly concerned about our jumpers here because I definitely bent those over in a bad way. But again, those jumpers don't feel like they would be the root of the problem here.
Can you discharge the caps and check if they're not open?
Yeah, I can check to see if they've even got any voltage on them right now.
I don't know if any of those serve just the would any of them fail in such a way that it would take out all the T3 stuff and not the drum itself?
I don't think so. I'm pretty sure these are all individual to each voltage rail. So if one failed, I would expect to lose a single voltage rail, but not all of them. And we got a bunch of bleed resistors. That's why they all measured 0.
I mean, if one fell short, we would have heard an angry transformer.
Yeah, we still don't really hear an angry transformer, so...
Which might mean that it's not getting power.
Yeah, all the voltage rails have a big bleed resistor across them, and then all the caps are in parallel with that. But the fact that we don't have any single one at all is slightly alarming. What is the AC check load on the schematic?
Oh, that's part of the warm-up circuitry. It actually actively checks for AC, T1, 5 volts, and I think something else. It has a self-check.
Where is that used?
And it's in the warm-up board. It's actively trying to test, am I seeing oscillation on T1? Yes, pass, and it just eventually lets the rest of the machine properly work. But I mean, it's not used before T3.
Okay. And it wouldn't.
We would be seeing voltages.
Yeah. Okay. So we would
Oh
be
wait,
seeing something.
does it? It looks like it crowbars 35 volts. It's on page 335. I'm just checking.
Yeah, it would be.
It's on page.
That's just one
335.
rail. It wouldn't.
Well, no. So it's not crowbarring a rail. It's crowbarring whatever C is. So that line
Oh, you're
C
right, you're
goes
right,
to
you're right.
ground when the voltage across the supply, and wherever line C goes, I don't know.
C probably goes to the master warm-up diagram, which is somewhere. I really didn't spend time in the warm-up diagram.
Well, I don't think that's our problem anyway, so we don't particularly need to spend time on it because I don't think C would cause everything to go down, right?
Yeah, it is just stopping the computer from running if it doesn't see all its. It's like you wouldn't want to write to the drum if you don't have your plus 35 volts. It's like,
Yeah.
because I think it gets used. Yeah, C enters in diagram in page 341 at the bottom.
Oh, yeah. Yep. I gotcha. And that goes into some NAND gate control that combined goes off to the next page, which is back up on 340, which is the reset line and line A. Yeah, that's not going to cause every single line to be totally dead.
No, it's just a check. If it doesn't see AC, it knows to gracefully turn off or something. It's like,
all right, I got to do something about this thing not being rotated.
Okay, you see power button actually is just hitting the C line.
Yeah, no, power butting is also hitting the C line. It hits other stuff too.
Right, that big. But yeah, that's one of the places it hits.
yeah, so it actively drains C line if it's. Well, I mean, the power button is actively toggling mains AC, but through a relay, which
All
is
right.
also mains powered.
That's not our issue.
Yeah,
And you know
exactly.
Relay K1 is working, right?
Sorry.
Relay K1 is turning on.
We're seeing fan spin and drum spin, so
So that's got to be working.
Yeah. So we raised the question of, did we blitz the transformer? Do we have a bad connection somewhere, a bad wire somewhere?
I mean, if we can see if there's AC getting to the transformer, because it's not exiting the transformer.
Well,
Yeah,
do you have
well-
how much access do you have to the transformer taps?
None.
How do we get that?
Painfully. Might be able to get this plate off, but that's the plate that holds the transformer. I could maybe get the whole transformer plate out, but that's not going to be graceful. I can see where the backside of F6 goes. I don't know where the front side of F6 goes. It goes down here to this terminal block. Okay, so it's going from 5 to there. Let me at least check, see if we're getting connection across F6.
Well, if it's accessible, that's the easiest thing to check.
Yeah, so we've got 0.2 ohms across F6. That's a good sign.
Oh boy. So then, do you think you can power it in its current location?
I don't know if you can. I mean, there's a lot of stuff unplugged. Let's see, that doesn't
test
necessarily...
continuity between F6 and... Oh, we have to figure out where the heck the relay is.
Oh, well, you've got numbers on there, 7 and 8. I've got those numbers on the bottom here.
Oh, nice. Check F6 to 5?
Yeah, so I checked from 5 to...
To the back of F6.
I checked from 5 to 4, I believe. Let me double check that here, see what it says.
5 to 4?
5 to 4 is looking at a coil on the transformer on the primary side.
5 to 4, you would be seeing the drum.
Yeah, you're right. I didn't check 5 to 4. I checked 5 to something else. I checked 5 to 2.
5 to 2.
Wait, which 5 and 2 are you guys talking about then?
Numbers on page 343. Oh, no, there's round numbers and square numbers.
Do they duplicate? Oh, yeah, I'm looking at the square numbers, not the round numbers. So the square numbers are blade connectors. The round numbers are the, like, Molex style connectors.
Yeah, I'm still trying to figure out what happens between 5 to 2. It's like,
So 5 would go...
it goes to an open relay.
Yeah, why do I have... How am I... Maybe I'm looking at the wrong 2? I mean, I followed the wires from both sides of F6, and that was where they went.
From 5 to 2.
I'm guessing 2. Like, it says 2, but it's on a separate board here, so it might be a different 2. Because I've also got 25 and 26 on here, which, you know...
Okay, if it's on a different board, that's good, because 2 was just your neutral. I'm like, how?
Yeah.
It's like...
So, it's...
So 5 to 2 connects.
Oh, I bet you... let's see. Well, I bet you T3 is 2.
Yeah.
If you're reading it that way, you're going to be seeing through the power relay. You're looking through the coil of the power relay, and probably the fan too. That's what you're seeing.
Is that connecting? No, I mean 5 is...
Oh, no. If you look on page 345...
Yeah, that
See how
one probably has.
it shows F6 there? See where it says
Yeah,
2?
Two is a tap. Yeah, that's what I was assuming.
Yeah.
Because you said it was on a different board, so I'm like, okay, it's not the 2 from this diagram, it's the other
Yeah.
one.
So I
But
checked.
5 to 2 works.
That's good. Yeah. I can check 2 to 1. That'll tell me what the primary coil is looking like.
Yeah, you should be seeing 2 parallel coils.
If I can get my probe in there. Which
I
should
would
be
assume,
a couple of ohms.
yeah.
2.2 ohms. That sounds about right. 2.1 ohms, 2 ohms. Yeah, it looks like it's going to stabilize at about 1.9 ohms.
That's on 2 to 1.
2 to 1 on page
345. That's where
345.
our originally was. Can you do 5 to 4 as well? That's the other primary.
Yeah,
They're parallel.
maybe. Yeah, they should be paralleled.
I mean, if we lost a parallel, we would be very low power, but we'd see voltage.
No, we're there though, and it's ferro-resonant, so I don't know what the hell the failure modes are.
That's a good point. Ferro-resonant may not like having that low. If I check 5 to 4, that is also 2.0, 1.9. So whether that's, separate or not, I should check.
Hot to neutral.
I should
And
check.
you should see
5 to 2 and 4 to 1 is what I should check. Because if we lost a wire in between there, so that they're no longer parallel, that could be causing.
Yeah, so 5 to 2 should be like 0. 4 to 1, same thing.
Yeah.
There's also those weird taps like 3 and 6. You got dashed lines. It's like,
I mean, I can
oh,
literally see the wire here. Oh, so okay. 2, 3, 4. That was 4. There's 5. 5 to 2 is 0.3 ohms. 4 to 1 is 0.3 ohms. All right, so we don't have an open primary. Our wires are connected up. F6 is making voltage across it.
I'm thinking the relay, the power on relay is on the module you remove, right?
The power on relay, no, it is bolted to the back panel here.
Okay.
I can kind of get to it. The power on relay would... The power on relay would prevent T3 from going.
Yeah, but we're getting drum spin.
Yeah, but I don't think drum spin is necessary for the power relay.
The power relay turns on the drum.
The power relay turns on bloody everything, but... Oh, you're right, yeah. So there's no way for box 5...
Yeah, box 5 should become live. Box 4 should become neutral.
There's 2 box 4s. That's fun.
Yeah, aren't they connected together? No, they're not.
No, they're not.
Great.
Yeah, I'm just trying to figure out if there's a way to get drum spin without F6. But I really don't think there is. Well, no, so
drum spin works without F6. Problem is,
Yeah, that's right. That's right.
nothing. The drum's parallel to the entire F6 T3. So if it spins, why no T3?
Yeah. Could we lose a jumper potentially? Like if I had a jumper break. Like if jumper A broke. Nope, that
You
would
lose the
stop
drum.
everything. Yeah, that would stop the drum as well. If jumper, what other jumper do we have? We've got jumper B. If we lost jumper B, that would also lose everything.
Now wait, box 7 has 2 outputs. One goes to the fan and the drum, and the other one goes to the power button and I guess everything else. So if that relay lost a contact, that could cause the behavior you're seeing.
But box 7 only goes to the fan.
I see 2 lines coming out of box 7, orange and another orange. So the fan and then the power button, S7A.
Yeah, but the drum's downhill of the power relay.
So what I'm asking is, are those actually 2 different? Is it a DP? Is there more than one? I guess what do you call it? Pole being used there,
It's
or the different things, or is it all just one?
almost impossible to tell.
They're powering they're severing neutral and live to the drum and the whole rest of the computer.
Okay. Damn, I thought so they're just doing. It looks like they probably just have a lug there with 2 wires coming out of it. It's not separate poles.
It's all encapsulated. You can't tell.
Got it.
It's got a bunch of wires plugged to it. 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 wires going to what I believe is the power relay. Does that make sense? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I guess so. I mean, I'm not seeing any reason why we shouldn't have any voltage rails at all.
How confident are we of just plugging it in right now?
Not very.
Because we can't probe anything when it's in the chassis.
Yeah. Well, I can't probe much anything when it's here either. Like, it's all encapsulated pretty well.
If you could probe 5 and 4 to see if there's 120.
I mean, I can plug that one in. I can plug that one in. I can get the jumper in, which I'm pretty sure is still not healthy. Like, the jumper is clearly broken. Also, I've got a ton of like regulation stuff going on here, but I'm guessing that's all after we get beyond something. Oh.
Regulation stuff would be probably 5 volt.
I think all the regulation stuff is on here.
Yeah. There's somewhat regulated and more regulated some of the rails. I think I saw like a minus 12 is just like 2 resistors. It's like, okay, fine.
All right. I mean, I can try plugging it in like this. I don't know if it's going to do anything. Because it doesn't have anything else, like none of the computers plugged into it at all.
Including the power switch.
Yeah, yes, including the power switch. Right, so plugging it into here is not going to gain us anything unless we know exactly which 2 to jumper across for the power switch.
Which would be...
I can see what you're saying, 14, 15, but I still feel like there's a lot of stuff that can go bad here.
Yeah.
Because I don't even know which 14, 15 that would be. I've got 2 connectors that go towards the computer. I've got PWPM2, I guess is the label of one. And that's not going to tell me which connector is which. Let's see here. Pin numbers in circles are for PM6. Pin numbers not in circles are for PM10. So pin numbers in circle are 14 and 15 for PM6. Let's see, there's PM2, PM4, PM3. You PM5. I'm guessing this has to be PM6 down here on the side. But I don't know which ones of these are going to be 14, 15. I don't know how they count. 1, 2, 3, 4, 5, 6.
Yeah,
14,
not the
14,
funnest game
15.
of just poking in a multimeter and seeing when it turns on. Or sparks up.
Yeah, that's the thing. Is like it could be these two, it could be these two, it could be these two, it could be these two. And if I get them wrong, we start a fire. I'm not super keen on starting a fire tonight.
Can you verify it on the machine with the multimeter? Be sure which 2 pins you're supposed to be on?
I'm not sure what this is going to gain us though. Like, what would powering it up here gain us? Like, what are we trying to check?
Power to the transformer and power post transformer.
Okay, so we know that power is getting to the transformer because we checked the connection between F6 and the secondary. So the question now is power getting to F6? Right, because I can clearly multimeter out between F6 and the primary of the transformer. So where does the other side of the transformer go? T3. We should check T3 to where?
T3 is part of that assembly, right?
T3 is the transformer.
Should it be neutral?
No, it's not going to be neutral until the relay is on.
So where's F1? So say we look at the 35 volt rail.
F1 is on the main board here, this board on top. That's after the secondary of the transformer.
So you should be able to measure something. There's so much stuff in between the two. That's the problem.
Yeah.
If you measure something to ground there, but you're looking across caps and everything else.
Yeah. So all I'm trying to do, like, what if we plug it in? What we're trying to confirm is that AC is getting to the primary of the transformer, right? We can confirm that without having to plug it in by just checking continuity up to the primary, through the primary, out the other side of the primary, all the way back to the looks like the contactor, right? So
I'm convinced that the primary is good. I want to look at the secondaries to see what you're getting at those fuses. We weren't convinced about the primary before we pulled it out.
Well, but it seems awfully strange for us to lose all 5 secondaries all at once, right?
Are the top fuse that we're seeing on top of the module, are those the fuse that are in the other schematic?
Yeah,
Like
they're on page 3. So these 4 fuses right here are on 345, and that's F1, F2, F3, F4.
Okay, so if have we checked before them if they had voltage?
No, we didn't. I didn't check anything when it was powered up because I'm not super keen on sticking my hands in the middle of all this while it's powered up.
Yeah.
I don't think they'd all blow at once. And you check them; they're still good.
Yeah, the fuses are fine.
In that case, it would be weird. There's just like a weird thing in the schematic, like near J1, J2, and J3. It's like weird switch diagrams. Never really understood that one.
Weird switch diagram? You talking about the slash lines?
No, I mean on board L, like all the secondaries, they're going through.
Oh, those are like big headphone style jacks on the front, so you can plug something in.
Yeah, it's a bit strange that if you plug something into them, it just cuts that line.
Yeah, because now you're going through whatever it is that you plugged in.
That's how you check your secondaries.
Yeah.
They're plugging in amp meters.
Even if those were bad, we would still have plus 13 because it doesn't have one of those.
Yeah.
And we don't have plus 13.
So we just slide it back in and just hope it was F6 not making contact?
No.
What's common to all of those? What's common to all the rails?
There you go. That's now we're back on the primary side.
No. Ground.
There
We somehow lose ground on the secondary side.
Does that make any difference?
Well, we're pretty sure that the primary side is okay.
Well, I'm still thinking that we can do a little bit more. We know that let's be methodical here for a second. Turn my multimeter back on. So we know that if I measure across F6, which would be box 5 on one page to number 2 on the other page, that we see low current, or we see low ohmage. So we've got a good connection there. We do see a direct connection between both sides of the primary. If I measure across that, we're seeing like 2 ohms, so the primary is not open. All right, so let's work backwards from here. Let's start with...
Just real quick,
the question is, it's like, where are we picking up ground to test the secondary?
Hang on. You guys are jumping all over the place. Follow me with following the AC for a second, okay?
No problem.
So let's work our way backwards, because I'm still not convinced that our power relay here is healthy. It shows it as only a single contact, but we could have multiple contacts inside the power relay, and one of those could have gone and caused an issue, right? I don't fully understand how they're drawing the power relay here.
That's why I wanted to test 120 volt at contact 4 and 5.
Do me a favor. Stop trying to get me to shock myself tonight. All right? I really don't want to die on camera. So let's stop talking about plugging this thing in while it's outside of the chassis. All right? So let's do as much as we can with checking the ohmage, okay? So let's check between box 5 and box 6, which is going to be doable, I think. TB1 is a terminal block. 1, which I think is going to be this one. What box did I say? Box 5 and 6. Box 6. Well, that doesn't make any sense because box 6 doesn't have anything plugged into it.
Well, there's your problem.
No, box 6 has never had anything plugged into it.
Which is odd.
Yeah.
Maybe it's a different box 6.
Yeah, I bet you that box 6 is going to the actual relay. Now, let's flip you all the way over. There's not going to be a good way for you guys to ever see what the heck is going on here.
Yeah, we haven't even seen that beautiful relay.
This is the relay, I think. It's the only thing in here that looks like a relay. All right. Let's see if we can follow. I've got, so on box 5 here, I have a black wire that goes to F6. And then I have 2 red wires.
Yeah. One goes to a connector,
And
and
one
the
goes,
other one should be going to the relay.
okay.
Do
I
you
should-
have markers for PM6, PM10, and TB1?
Not for TB1, but I'm guessing that TB stands for terminal block, and there's only one terminal block in this thing.
Okay, so the squares are just the terminal block then.
Yeah.
Got it.
Okay, so I do have a 0.3 ohm connection to one leg on the relay box. So we got a clean
Okay.
connection there. All right. So that's going to come out and go to if
So
I'm
do you have a
guessing
white
it's that
and
one.
blue wire?
So that's going to come out and potentially go to box 4, which is also going to go to box 3, which is black, right? Box 4, I'm guessing is also on the relay. So I should have a connection between box 3 and somewhere on the relay.
Yes.
Right. Exactly.
Yeah, and I do, 0.4 ohms. Okay, now from box 3, we're going to go through jumper A, through F7, to box 1, which should be black from the cable.
Yep.
And I don't have a connection to box 1 from box 3. And I can see clearly that box 1 is the black wire coming in from the cable.
Okay, so everybody give points to Sagi for finding that a jumper is bad.
Well, no, we don't know that yet. Hang on a sec.
It looks like your famous jumper.
Well, no, it looks like it could be F7 giving us grief. Which doesn't make any sense, because then the drum shouldn't rotate, but...
I mean, we're a bit past that point, because if it's the jumper, the drum should rotate either.
Yeah, F7 is good. All right, so let's go...
But you're not getting... you could test to the end of the wire.
Well, hang on, I'm trying to follow this guy. This guy goes to F7. Coming out of F7, we go to U, which is going to go to the drum. So I should have a connection here. And I do, 0.3 ohms outside of F7.
F7 to terminal 1 works?
That's where I am, yeah, F7 to terminal 1.
So if you don't see something between 1 and 3, it's your jumper A.
No. Well, here's the thing. That's a different jumper.
That's not great.
So where the heck is the jumper? I'm looking at a different jumper then. So jumper A and jumper B is not going to be the one that's broken on top of the thing. That's going to be on
the board.
Yeah, it's going to be on the board. So what plug is that that's on the board that has broken wires in it? Is it board, not board L? It's going to be the one with the fuses, so it's going to be board N. And I swear to God, this does not show me anything about what's on board N.
Board N is page 348.
Yeah, I'm looking at it, but there's nothing on there that looks like the little jumper plug that I broke.
I know.
All right, hang on. Where's my water at?
Unless the remote sense. How many pins are on the jumper that broke?
Hang on, just
Oh, it might be the remote sense. They might just be shorting that out.
All right, let's see if we can figure out this jumper problem here. Everything else looks copacetic. This big guy on the front here is worrying. It is PM5 is what it is labeled. Not that that means anything because that's not shown anywhere. Unless it's on the 5 volt. Is it on the 5 volt reg?
When the processor is undergoing margin testing, the jumpers connected between 1379 and PM5 are removed. Okay, hold on. What is that?
Where is PM5 on the schematic?
According to the OCR, it's only mentioned on page 347.
Great.
I'd look at the next one because it's rotated. The OCR wouldn't see it. PM5, it's a black wire in the diagram next to Q100-1. Like close to the remote sense.
How are you seeing that PM5 anywhere there? Oh, I got you. 7, 9, and 1 and 3 is going to be PM5. Gotcha. That is either removing or adding that. So that's going to affect remote sense. Is remote sense capable of shutting down everything?
Not to the extent, no. I mean, actually, I don't even know where that remote sense goes.
Actually, if you look at page 346, toward the end of it, it talks about failure modes. In the event something fails and the regular output tries to go below ground, CR69 becomes forward bias and clamps the output to ground. It sounds like they have that for multiple loads. But then they talk about that voltage check, though. They're adjusting R402 to 5 volts plus or minus 30 millivolts.
Yeah, that looks like because all of that circuitry is like in trying to influence, I think. No, it's not even influencing plus 5 volts.
Well, okay. I can check between R385 and R390, and I should see less than 100 ohms, right? R385, R390. Yeah. So there's R390, there's R385. So if I check from here to here, I should see less than 100 ohms. 87 ohms. So this is clearly still somewhat okay. But I think that would just kill our 5 volt rail only, though, right?
Actually, it's influencing plus 35, that one.
How do you see that?
I mean, nothing of all that part of the circuitry is touching the 5 volt rail. It's overlapping it, but it's not doing anything. Or
That's
almost.
just, I mean, if reading the manual, I'm sorry, reading the stuff on page 346, they're setting the 5 point. This is the protection if the 5 volt rail goes above or below what it should.
I'm getting lost because I don't see any ground symbols in here. Like, where's my reference?
On the bottom is where ground is. So they're using the
Yeah, for the-
remote. They're using the remote sense to turn Q101 on or off. And if Q101 is on or off, let's see here. That is affecting the 5-volt rail in some way.
Yeah, but that whole part of the circuit is like completely floating without more information.
No, you got all the information you need right here. We're just not smart enough to figure it out yet.
It's like, if remote sense negative was like ground, yeah, it would be affecting, but it's like,
Look at page 344. The text where it says plus 5-volt regulator. This is remote senses wherever they're using the 5 volts. They want to make sure it's exactly 5 volts over there, where wherever in the computer that is, on the CPU board or whatever. So it can grow higher. It can be higher than 5 volts at the supply, whatever it needs to be. To be 5, they're making sure it's 5 volts on the board. If you the text explains it.
To my AC problem here.
so remote sense negative would probably be a ground reference. Yeah, so that, yeah, thanks. Now the diagram makes slightly more sense.
Remote sense negative isn't necessarily a ground. They need it separated from ground, because if it attempts to go below ground, they also fail it. They'll also cut it off.
But the point is that that's all part of the 5-volt regulator, which means that if that goes bad, we're going to lose the 5-volt rail, not absolutely everything.
Yeah.
So I should have a direct connection from you.
Yeah, we should be going back to measuring where the AC is, because didn't we find an open that wasn't supposed to be there?
It's not necessarily that we found an open that's not supposed to be there. We found a jumper that we didn't understand. You're going to plug in there, which is going to jumper straight across. So there is a jumper right there on that one. So I should have direct connection between you and you. Yes. That's going to come back into you, which then should go to box 3. Yes. Okay. Now box 3 should go through F5 to 14. So you're 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13, 14. That is also correct. So box 3 goes straight through 14. So I believe we've checked the entire path from T3 box 5 all the way through back to the black wire coming in from the wall, as well as up to the power button. So now let's check the white wire. That's our neutral. That's going to come in from pin 2 and go to 3. That's going to come into block 2 here, which I can see is indeed the white wire on our neutral. And that's going to go to square number 3. 1, 2, 3. 0.5 ohms. Now 3 says there should be a jumper to 6, which is right next to it. And there indeed is a jumper to 6. I should check the quality of these jumpers. Yep, those are both good. Now, when we come out of 6, we go to 1 on the power relay, which is going to be you, I think. Yep, 0.5 ohms. Okay. And then out of the power relay is going to be 3, which is our white and blue, which is you. And that's going to go to fun box number 4. 0.5 ohms. Okay. Which we were pretty sure was correct. Now 4 is going to go over to T3, which is going to be pin 1 on T3 here, which is you. That is also 0.5 ohms, which I'm pretty sure is just the internal resistance of these guys. Okay, so
Did we check from the coil of T3, like to the fuse? I think, yeah,
we did.
did a long while ago.
Yeah, we checked it. So T3 should absolutely be seeing real deal AC on it from the wall going in, which says that something is preventing all of our secondaries from coming up. Now, if one secondary had a dead short on it, like let's say that one of our rectifier diodes shorted, would that be enough to pull all of the rest of the secondaries down? I mean, I can also just check the diodes. They're all on board in, which is right up top. Should have a boatload of diodes up here.
While we're at it, it's like just like testing if there's a dead short on between like J1, J2, J3 to whatever ground reference is available.
Well, pretty much any of the plugs on the front should tell us that, right? We've got ground, and I've got all of the output power plugs on the front here.
Yeah.
I mean, that should absolutely, like, if one of the rails is shorted, that's going to tell us here, right?
Except
Yeah,
if we lose the connection to the ground lug, that is the...
Well, J8 is ground. They give you a specific ground lug up front. Here. So I should be able to check across, say, like J7, which is going to be our plus 13 volt rail.
And we should see like at least 750 ohms.
Well, yeah, it's going to start low and it's going to build its way up as it charges up the capacitor. Right.
And
so
you guys know about the other diagram on page 383 of the whole power supply and all the jacks, right?
Page 383.
Page 345. Yeah.
383.
383.
Oh, yeah. That shows you where everything is, kind of.
Yeah, there's 382 and 383. Between those two, it gives you the layout of everything you can access when it's more or less in the chassis.
Yeah. Unfortunately, all that stuff is marked for me, so that actually benefits you guys. But their silk screening is actually really pretty good.
Oh yeah, it's incredible.
Yeah, so we don't have a dead short on plus 13.
And we confirmed that your ground is actually ground.
Well,
Or
that's
else
what it
we
looks
wouldn't
like.
see the cap.
Yeah, minus 24 is fine. Plus 18 was a little low initially. It was down at like 20 ohms initially, but it's building up over 100 ohms now.
I mean, it's powering a lot through plus 18. I
Yeah,
think.
plus 18 must need a lot of juice.
It's a 4 amp fuse.
Yeah, that's the big boy. Let's see, plus 35. It started about 50, but it's charging up really fast, up over 2K. So we don't have a short on any of the output rails. I mean, I'm not seeing a smoking gun or anything obvious here, or anything at all that makes sense.
Just for the kick of it, can you test the end of the lead to like both the jumpers?
Yeah, that's
like line and neutral.
Oh, you mean the actual plug? Like the actual plug that goes on the wall?
Yeah. Like to, like say, like to the relay.
You're just wanting to check the integrity of the plug, right? Like if my power cable is okay.
More that I just want to make sure that we've seen all of the wire, and we just didn't accidentally just forget like a, I don't know, mini section somewhere.
So I've traced out the AC all the way up to the relay and from the other side of the relay. Now I'm checking the AC coming in. The wire is showing 0.5 ohms, which again is probably just the internal resistance of my two probes. If I touch the two probes to each other directly, they're at 0.2 ohms.
Yeah.
So my AC plug is okay.
All the way to the, all the way to the power relay, right?
Oh, geez. I don't remember which one of these is the power relay that I'm going to be able to check that at. And actually, no, I can't check it all the way to the power relay because it has to go through the jumpers that plug into the side, which are currently unplugged because it's a long ways away.
Oh yeah, especially the power on switch. Terminal block 3.
Yeah, no, so I checked it on it on the terminal block. We're good. It's making it there.
Yeah, okay.
I mean, we were pretty sure that AC was coming in just fine anyways because, the drum spins.
So is there any way we got to figure out what's going on with that relay somehow?
Well, the thing is, right now we're pretty much past like everything that's high voltage, and we need to probe on the top board. Ish. It's like best case scenario, we slide it back in and it just works.
Which is kind of what I'm thinking might happen because it could just be, corroded contacts and stuff, right?
Yeah, or just like F6 was still not making good contact and we just jostled it and there you go.
Yeah, we'll see. We'll find out. I don't think I'm that lucky though.
Yeah,
it's probably not going to be that easy.
I mean, the problem is it's not that easy till it is, and then you can't find anything wrong because it was easy.
Well, no. So if it just works now, then that tells me that we have a one of these Molex connectors has a questionable connection on it.
Could be.
But I wouldn't go wiggling and jiggling with that thing powered on.
Oh, no.
Not unless you have your 600 volt gloves.
No, you would be wiggling and jiggling, but not from your own response.
Again, I've been trying to keep you guys from electrocuting me all night. All right. I mean, it's entirely possible that, one of these connections got a little hot. and stopped making good connection, which cut out all of our power. And just by unplugging it and plugging it all back in, you know, we break whatever corrosion had been developing on it, right?
Yeah, let's just not do that with the card edge connector.
Yeah.
Yeah.
Let's not say we didn't.
All right. I'm not going to put the power supply locking plate in for now, but don't let me forget to do that before the end of the day. Make sure that it's not shorting across anything. I'm just going to pull it all the way out, set it down over here. That way that big hunk of metal can't hurt anything. All right. Because it was very odd that it just was working and then suddenly wasn't working.
Yeah.
And I would expect us to lose one rail, but...
It seems like too much. It's like, I would have assumed just the 5-volt one would have been enough to, like, cause the problem.
Well,
But
yeah.
All the rest are not there.
If we'd have just lost one rail, then we would just troubleshoot that one rail, but losing them all is annoying.
Yeah, you wouldn't lose them all independently at once. That'd be pretty weird.
Yeah. Still no lights. That's super frustrating.
Still fan spin and drum spin.
Yep. Still got fan and drum.
And the drum is in parallel with T3.
Yeah, it's still nothing on minus 24. Nothing on plus 18. Nothing on plus 35. Nothing on plus 13. All right. Now, let me see here. The fuses. I can check on either side of those fuses. Yeah, 0 on all the fuses. Yeah, wiggling that guy around didn't do anything.
I wonder if we could try using the jacks to just use the power supply to eject on the 18-volt rail on the secondary with nothing else powered and just see if that brings the lights up.
I didn't quite follow that. You're still super bassy, and my bone conduction headphones have a hard time conducting.
Yeah, I'll try to relay that. Trying to power the secondary from an external supply to just see if the lights turns on.
Yeah, so because you have those headphone jack things there that you mentioned earlier, could we just inject some voltage and see if from that point onwards it's fine or it's further down?
Yeah, I'm not super keen on that. I'm afraid it'll hurt something else beyond what we've already hurt. I am starting to wonder if C105 potentially went down, which is going to be the AC relay for the ferro-resonant part.
Is there a way to check that?
Yeah, I don't know how you check an AC relay.
Carefully? I mean, we should be seeing, like, at least some millivolts, right?
Yeah, but if we lost the ferro-resonant part of a ferro-resonant supply, I don't think you would conduct at all. Right, because C105 is a 440 volt AC capacitor. That is definitely the LC tank circuit for the ferro-resonant supply. If you lose your LC tank circuit, the ferro-resonant supply is not going to resonate, which would kill all the other secondaries.
But I would assume to see at least some minor amount of voltage, no?
Nah, like like assume that you're generating. Yeah, maybe you're generating a couple millivolts, but check it out. You've got 750 ohm, 1.3 k ohm, 2.4 k ohm. These bleed resistors from ground to the positive of each output, to the DC output of each one. So if you're producing a couple of millivolts, or even if you're producing 1 volt, like if you have no current driving, or even if you're producing 24 volts, but if you have no current behind it because the ferro-resonant supply isn't ferro-resonating, those bleed resistors are just going to hold everything to ground because you don't have any current to push past them.
Yeah. It's like we should be testing maybe for dead short or full open on that AC cap.
Yeah, that's what I'm going to do. But I got to pull the whole thing out to get to that.
One thing I'm checking is the failure latch circuit, which is essentially where everything comes together to control all the rails. But from what we're seeing, that's not even coming into play, right?
The failure latch circuit. Oh, the AC check circuit? Wait, which circuit are you talking about?
I'm trying to find where it actually is. So Q37 and Q41, let me find out which board that is. I'm looking on page 337.
Yeah, just a second here. Looking on page 337. Failure latch circuit. Shown in figure 4.43. Where's figure 4.43? That's
page 306.
Lamp driver circuit.
I don't see failure latch there. I'm not sure.
Yeah, I don't see failure latch here either. I think maybe they labeled something wrong.
306 is
No, that's figure 4. 4.43 is the page. You're looking at figure 4.29.
Oh.
They got you.
They got me again.
Yeah. See, there's 4.40, I mean. There's 4.42. It's going to be on like 338 maybe. 339, 340. $41. So it's in 341 somewhere.
That
341 or
makes more sense.
341 or 340. It's on one of those two pages. I don't know what on these pages of the failure latch circuit, but it feels like this is back to that remote sense stuff that we were seeing in some way.
But does any of this stuff matter if we don't have rails to begin with? That's what I'm trying to figure out. Could this be what's holding the rails down, or at least part of it?
Holding all the rails though? Like, I'm trying to figure out like what impacts every rail,
Actually, just mentally, how do you hold all the rails down if you don't have power to turn on a transistor?
I would think it would be...
You need power to crowbar something.
Well, if they're keeping it out of resonance somehow, I'm not. That's where I'm not sure how the failure modes on these supplies.
No, I try to go for the cap, but
Okay, yeah, I figured it was worth a shot.
yeah.
Well, I mean, it's a circuit that says failure in it, so it was a good shot.
I see. Let's see. 35, 18, and 5 are there. That's it.
Yeah, but yeah, it's not even testing the minus 24. No, there's a minus 24 here, but it's behind 2 Zeners.
All right. We've got our big AC cap in there. Let me make sure that I'm not just gonna electrocute myself on stored energy and capacitors right quick.
Would be interesting to see what the DC voltage is on it right now.
The DC voltage on any of these capacitors should be 0 because they've got really big, really nice drain.
The ferro-resonant one
Leads.
doesn't have a resistor.
Yeah, I'm gonna check it once I make sure that I'm not gonna hurt myself with.
Again, not
No,
trying
take
to
your time.
trot the Usagi.
We got nothing. We have nothing to lose here, and you've got fingers and hearts and other parts to lose.
Yeah.
Yeah.
I've worked on big photo strobes, and
Okay, that's
that's
0
when
volts.
those are times when I said no and backed away, and I'm not. This is it's always okay to say stop.
Yeah, so I'm showing 1.5 ohms across that resistor, which makes sense because that resistor is in parallel with a winding of the secondary. So I can actually, let me unplug one clip from that and check the capacitor by itself. I did check it for, I checked it for DC. I wonder if it's like, this is my brain at midnight going, I wonder if the capacitor and the LC circuit are resonating still with some form of AC voltage, but no. Yeah, they're fine. Everything's at 0 volts.
That would be hilarious.
Yeah.
Like, my LC tank circuit keeps jiggling for some reason.
I know, right? Right. Like, it's one of those things where my brain was like, no, that's impossible. And then, like, the animal part of my brain was like, yeah, but it could hurt if you were wrong. Right? All right.
Which is the LC tank cap or circuit section again?
Let me, it's on what page was that? 345 maybe? Yeah, 345, C105. It's the 440 volt AC cap.
Jeez, okay.
So I'm measuring, again, I don't know how AC caps work. I'm measuring 1.8 ohms across the capacitor.
So it's not open and it's not a dead short. I mean,
but
it could be open. Like that could be just winding.
No. This is the capacitor isolated. Just the capacitor.
Isolated.
So if I check DC caps, they start low and then they, charge up, right? But like, what makes an AC cap different from a DC cap? I would expect the AC cap to start charging up, not just sit at 1.5 ohms, 1.6 ohms the whole time.
Yeah. I mean, I thought, like, I didn't spend much time with AC caps. I know they're in microwaves, and I know not to touch them.
Yeah, I don't know. That's my problem, is that I don't know enough about AC caps to know, but this feels suspicious to me, man. Oh, if I check just the winding's at like 11 ohms, 10 ohms. So the capacitor has a lower ohmage than the winding. That's now sitting at like 2.3 ohms, huh?
Yeah. But if it was like a dead short, that would be shorting a winding. That would be collapsing like the field and stopping everything from working.
Well, no, it doesn't have to be
if you
a
have
dead...
an open winding, you don't have connection.
It's not the winding. And it doesn't have to be a dead short in the capacitor for the resonance to not happen correctly.
Yeah.
AC caps are supposed to be the same as DC caps. That's a few people who are saying that.
Yeah, the AC. If you search AC caps, it shows air conditioning stuff. I've never heard of an AC cap.
I mean, AC caps are in air conditioning systems because they're in like motor start load.
Yeah.
And
It's just a big cap. It's a big or a split capacitor. But
I'm gonna get it out. I'm gonna pull it out because I am suspicious enough of this capacitor that I'm gonna pull it out and put it on the LCR meter.
what's the value of it? Is it 4 microfarads?
Yeah.
I see a 4 on the schematic. That's what I'm asking.
Yeah, it says 4.0 on the
Then
on the cap
go for
itself.
4.0 microfarads. Yeah.
And it's a can, right?
Yeah, it's a big old can. I'm about to pull it out so you guys can see it.
Sorry, Philip on the chat is saying that he thinks that cap's gone bad.
Yeah, I think that cap has gone bad as well, Philip. I think you're onto something.
So we got super/lucky/unlucky that we just lost Ferro-resonant.
Yeah.
No, that's good. That's better than the supply dumping something it shouldn't into the computer.
Yeah.
We're unlucky in that I need a better screwdriver, but we're unlucky in that I don't think I have another one of these. I don't just carry around a bunch of 4 microfarad AC caps.
Like, that sounds like a normal person thing to say. It's like I don't carry AC capacitors.
Yeah, we might
we're
have
in electronics.
We might have a motor start capacitor out there, but from like a swimming pool motor or AC, we might have a spare motor start capacitor out there somewhere, but I doubt it's going to be exactly 4 microfarads.
No, you can get them. They're about $5.
Yeah, they're not expensive, so I should just get the right one.
And if you get the wrong one, I don't know what the supply is going to do. I mean, looking up motor start caps, they're in like 480 microfarads.
Yeah, they're big.
Yeah. At this point, I think the value is important. It's something about the word resonance.
Yeah, dude, I have an entire video about ferro-resonance power supplies, man.
Yeah.
Have you? Is this your first experience with a ferro-resonant supply? There we go.
I would say so.
They're like wild beasts, man. And if this cap went, I could absolutely see that causing all sorts of problems. I mean, I don't see any reason why we should lose every single rail except like there's no reason that we would lose every single rail simultaneously unless it was something that affected every single rail, and we've proven that F6 was fine.
Yeah. Well, after minor repairs, but yeah.
Take off hold there.
Like, doesn't seem to be LCRing much.
Well, let me slow the frequency down to something that it's expecting. 100 hertz is as low as I can go. But it's supposed to LCR at 60 hertz, right?
Or whatever multiple it wants.
Yeah, it's just not detecting anything.
Zero capacitance because it's a short.
Yeah, I don't know what's going on here.
Shouldn't it at least detect it's an R?
Oh, I got it. Somehow I keep putting it in hold. There we go. That's at 100 hertz. Let's take it out of ESR here. I don't want ESR. Show me capacitance, man. I really wish I knew how to use my own goddamn tools. There we go. C. All right. Give me a capacitance. Give me a capacitance. It's just saying OL as though it doesn't detect it.
SD's dead, Jim.
Yeah, I'm pretty sure we have located.
Right here, we don't have a cap. We have an R.
Yeah. Okay, so it tried to. So I flip it over to auto, and it tries to detect capacitance, and then it automatically switches over to resistance and says 1.77 ohms.
That's a resistor now.
Yeah, which is what I was measuring. Like 1.7, 1.8 is what I was measuring with the multimeter, right? With this guy.
Caps are a short at AC and an open at DC. And the meter is trying to figure that out, and the cap's not acting as it should.
Yeah. Let's see if let's see if my multimeter can see what the multimeter says capacitance wise. I mean, the multimeter is pretty terrible at detecting capacitance anyways, but yeah, I think
Does it rattle?
nope. Probably for the better. It's probably full of a bunch of PCB that'll kill me.
No, but Pentium found a bunch of Maxwell's in one of his supplies, his mini computer supplies that were actually dried out to the point of rattling. Usually those bulge, but in like AC, air conditioning. But this one looks okay.
Yeah, this makes me wonder, because I've got a spare Centurion power supply. Part of me is going, the Centurion is a ferro-resonant power supply. Go steal the ferro-resonant cap out of it.
Yeah, if it's a similar value.
Yeah, but that's all the way up in storage, which is like a quarter mile down the road at midnight with no electricity up there. Maybe not the
Sounds
best
like
time.
A bad deal.
Yeah. I wish it was down here. I'd go digging through it.
That's the only place you'd have a spare one.
That or in the Data 620. I could steal one out of the Data 620 maybe.
Yeah, again, it would have to be similar, or like.
The Data 620 is a ferro-resonant machine. And I can see the AC caps on it. But they're so rusty that I can't read what the values on them are.
So
Excellent.
it would be a pain to clamp an LCR meter on it and just see if it's 4.
Well, also the wires are soldered to them.
That's a secondary problem.
Connectors.
Yep.
Yeah. Yeah, I'm trying to think of what else I got in here that's got a ferro-resonant in it.
Somebody's asking if this Litten is compiling BASIC yet. I've looked at the specs.
It's not even compiling
Probably
AC. Yeah. Yeah. So, yeah, Thor Drake, it appears, to the best of our troubleshooting knowledge, that we lost the AC capacitor in the ferro-resonant circuit for the ferro-resonant supply, which would be in line with what we're seeing of all the DC rails going down. Yeah, KD5, I'm surprised it didn't pop and hiss either, but I mean, there's no sign of bulging on this thing. There's no smell to it. There's no leakage. There's no indication
not-
that it would have gone down.
It's not it's not pulling tons of current like a motor start would, right? It's just there to resonate.
Yeah, it's just there to resonate. So yeah.
Yeah, I was going to ask, like, how many amps are we expecting to go through that cap?
Not much. It's just the resonant circuit.
It's like the base of a transistor in the electromagnetic world.
Yeah,
You
but
kind of think of it like that.
But
Yeah.
the thing is, it's like we have. Is it a special winding, or is it just one of many that are all identical?
It's a completely separate winding from all of the rest.
Yeah, it's a separate winding, but are we expecting it to be
I
like?
mean, not, when I say separate winding, I mean like physically separated from the rest of the windings. As in,
Right,
there is a gap the size of my finger in between the resonant winding and all of the rest of the secondary windings.
Yeah, but
right,
I mean,
if you look at
the other ones. Sorry,
the
the
link-
other.
real quick, if you look at the link that I posted to his video, to Asagi's video, you see the two sets of windings in the Centurion supply. The smaller winding is that's just there for resonance.
Okay, so it's actually smaller than the rest. Because I was going to ask, the other ones are pulling like 4 amps. So it's like, are we expecting 4 amps to be able to dump in a similar winding?
No. All we're
Yeah.
expecting, to be honest, I don't know how many amps are going to go through the secondary winding, but what the secondary winding and the resonant circuit is doing is it's pushing the entire transformer into complete and total saturation. Like that's where it's supposed to live. And so importantly, if you don't have the resonance going on, the entire concept of how it's shunting electromagnetic force into the rest of the secondary windings falls apart. So the secondary winding here is not providing the current for the rest of the secondary windings. The resonant winding here is not providing the current for the rest of the secondary windings. The resonant winding here is just providing a magnetic shunt to push the transformer into saturation, and all of that current is coming from the main AC. And I can tell you by looking at the dinky wires that are plugged into this that you're not cramming 4 volts or 4 amps at massive voltage through it.
Yeah.
Like it's not going to take much.
That's essentially what I was asking, because the other windings are able to do 4 amps. That one's different enough that we're going to expect less than 4. So that's why it doesn't go kaboom.
Well, yeah, but I mean, capacitors can go kaboom and leak even with like 10 milliamps on them, right? It doesn't take, like, capacitors leak and die all the time. It's just these guys are super sealed up.
Yeah, but I mean, it's still just like, if it was like just 1 amp, we would be like seeing like what 1 watt of dissipation through the whole can. Yeah, that would be hot.
Yeah, this
I mean,
one is.
that's expecting 1 amp. It's like it's 100 milliamps. It's like,
Yeah. Let's see. In that video, do I actually show what capacitance the one on the Centurion is? Where the heck did Discord go?
disappeared.
Yeah, why did my Discord go away?
Like
No, I mean, I had Discord open on the Linux laptop here, but apparently I somehow miraculously closed it. Or it closed
got
itself.
Got somebody commenting on the Discord about the tolerance range. Like, he's expecting 3 to 8 should be good enough.
Yeah, BK 1602. Yeah, I think you're probably right that it's got between 200 and 350 volts on it. I mean, it's a 440 volt AC cap. So yeah, 300 to 500 milliamps sounds about right. That's kind of what I would expect. The Centurion is such an aesthetically. It is Z Snails. The Centurion is a beautifully aesthetically pleasing computer.
But this one looks like a washing machine.
Yeah. Centurion looked at the
Yeah.
Lytton and was like, "We gotta get some wood grain on this thing, and maybe some blue paint." I'm trying to remember if I showed Discord, man. What are you doing? Apparently, my Linux laptop has. There it goes. Jeez. I was going to try and pull up the video that I did talking about ferro-resonant supplies with the Centurion and see if I showed the Centurion supply to see if see if it's the same 4 microfarads.
The problem is I remember seeing it, but I remember being a while ago.
Yeah, it's an old video, but it's one of the few that I'm like really proud of because I did a huge amount of research into how ferro-resonant supplies work, and like there was nothing on YouTube at that point about how ferro-resonant supplies worked. And they're still they're still a mystery. You still people still see them all the time and don't recognize them as ferro-resonant. And sometimes like somebody will hear a power supply that hums and they go, "Oh, it must have delaminated windings or something." You know, they just immediately assume that something's gone wrong. Yeah, you can't, in that supply you can't see the.
Well,
you can't
that's
see the markings
one
on
of our
the AC
biggest
cap.
problem. This one is not humming.
Well, yeah, it's not humming because there's no resonance going on, right?
Yep.
Because it's not getting pushed into saturation. But people hear the hum and they go, "Oh, it must be, you know, the laminations on the core are bad." But that's not the case. Like the ferro-resonance just hums. They make that noise. That's part of the like quirk of what they are. And so a hum out of a ferro-resonant supply is totally normal. Philip, you can comment wherever you want. I'm more likely to read it on the Twitch stream, but I'm pretty behind on checking comments on either because I had the head buried in the machine for so long.
I mean, it's hard to read when you have your head and your hands in potentially 120 volts.
Yeah, 4 ohms, man.
Looking at the ferro-resonant video transcript, I see mention of the filter capacitor values, but I did not see a mention of the resonant capacitor value.
Yeah,
It's
so the
mentioned.
filter. Yeah, I think it's because the resonant cap is crammed right up against the side of the transformer. And so I couldn't read it. So I probably didn't even mention what size it was. I am going to have a bit of a wander through the garage. I may go out of range. We're going to test the range of the headphones and the microphone here. Because I know that we have some stuff.
What's stopping you from looking at the Centurion that you have here?
I don't want to pull it completely apart because it functions at the moment. I'm a bit superstitious about that stuff. If it works, I don't want to mess with it too much. Just to see
what the value of the cap is, not to actually pull it out.
I would have to take quite a lot apart to get to to get to where I could see the cap.
Yeah, it's buried, right?
Yeah, it's deep in there. Yeah, let's see. We've got... Like, I know we lost the cap on our pool motor at one point in time. And I've got it right here. But that one is 30 microfarad. It's a little fat.
Yeah.
Dang.
Slightly high.
Yeah, that was my hope. Well, at least I know we got it, but I obviously cannot use that. What else do I got that might have a ferro-resonant cap in it? Let's see. The Hawk drives, those are all raw linear.
The LGP21.
Ooh, that's
Or
a good
30
guess. Yeah, the 21 that's in there, that might have a ferro-resonant supply in it.
You got any fans?
I got lots of fans, man. They're wonderful people. They're keeping me afloat.
Well, only real fans. I mean the fans that move air.
No, I don't have any actual fans like that.
Yes, we do.
If you had like a
air.
shop fan, that would some of those big not big, but the shaded pole or split capacitor motors, split cap motors. I'm thinking of. They're around 4 microfarads.
Well, the LGB21, I believe, is just a brute force linear.
Rats.
That's not surprising.
Yeah, I mean, 1963, that seems about right. No, I am wrong. It is a ferro-resonant. And it has a 6 microfarad 330 volt AC cap on it. I would be afraid of putting that in there for fear that it would... 6 microfarads and 4 microfarads is close, but they're not the same, right?
Yeah.
Somebody was
And
commenting
it's a lower
like,
voltage.
Data would be slightly scared of.
We don't want to
Yeah.
electrocute you. We also don't want to burn you with hot electrolyte today.
Well, more importantly, I don't want to melt a winding on the power supply. Physically, I can heal, but I'll never get over the mental anguish of having to rewind a power supply. Or a transformer, I mean. But it's cool that the... Oh, you know what? I bet it is brute force linear, and that AC cap is not for a ferro-resonant supply. I bet it's the motor start cap for the memory disk.
Oh.
Now you guys got me curious. I'm gonna look at the manual now.
Now you have me randomly Googling. So ceiling fans,
I know, right?
wall fans, and stand fans. Basically, anything that has that plastic box, those are usually in that range. But I don't know if I'd recommend putting a plastic box in place of that big metal can.
Yeah, and I can just order, like, I can, just buy one. They're, like, not expensive.
You know the term "go fever"?
I do not know the term "go fever."
It's used in air crash investigations. That's what causes a lot of airplane crashes.
Yep. Yeah, I get what you're saying now. I get where you're coming from. We gotta go, right?
Yep.
Don't leave ground without actually knowing you can go back to ground at a reasonable speed.
Yeah. The smart play here is to order one and put it in next weekend.
And have a new known good rather than something we pulled out of another plastic piece of hardware.
Yeah. Yeah, exactly. All right, let's see here. F1 is for the disk motor. Those are thermistors. I mean, the LGP21 is on the docket. I kind of wish I'd started on it before the Data 620. I think it's way cooler than the Data 620.
And the Data 620 is not very straightforward.
Yep. C6 3.75 microfarad is part of the disk motor wiring. So yeah, that AC relay that I see in there is the motor start capacitor for the memory disk. The actual power supply is, surely there's a regulator somewhere. But it's brute force linear. It's not a ferro-resonant or anything fancy. And I swear, it doesn't even look like it's regulated, actually. It looks like they just rectify it and then smooth it with some big caps and then send it out.
Classy.
Yeah. I mean, unless there's a whole, like... Because now it's just into, like, the tape punch and the flexo writer schematics. That's the whole power supply schematic. Is literally just, like... Not even a linear regulator. They just rectify the secondary and smooth it and then send it. What the heck? Go LGP. This is madness.
I mean, does this predate ICs?
Like, I gotta be... Yeah, this is pure transistor.
Okay, so they're having fun.
They're generating negative 20 volts, negative 15 volts, plus 15 volts. And then they have a 24 volt AC for the panel lamps. And that's it. So all of the logic is plus 15, minus 15, and minus 20. Oh, so it says it goes to something called the distribution board. I wonder if they're doing regulation on the distribution board. No, they aren't. The distribution board is quite literally a board that distributes it to different places. They didn't even give you a schematic. They just give you a list of connections. Okay. Yeah.
So we're like expecting it for that machine is going to be a lot like the 620 essentially, like DTL.
Yeah. So I'm fairly certain. I mean, we don't have to reverse engineer anything, thankfully. I've got all the schematics, but it's all PNP stuff. You know, from ground to a negative voltage, with like set up as multiple NOR gates and stuff like that, right? Like they don't even use diodes to create their NOR gate. I mean, they have a lot of diodes in this thing, but like a lot of their NOR gates are just tin resistors into the base of the PNP. I guess NOR gate, NAND gate, it's PNP logic, so that might be creating a NAND gate.
Oh, they're not going DTL, they're going RTL.
They do have some DTL though. So it's like a mix of RTL and DTL.
Skimping on diodes, we see.
Yeah. LGP21. I don't know if this manual has been scanned and is on BitSavers. If it is, then I won't scan it. But if it hasn't been, I'll have to scan it before we start work. Because this manual's got the entire schematics for the entire machine.
I mean, the Lytton one more or less also has that, but if only they documented their flex connectors.
Yeah.
They documented where they start and where they end. I'd like to know each conductor where the heck they're going.
I think that's all in the run lists at the end of the manual.
I mean, it's saying from one point to another. I think I saw like one or two connectors that say it's going through a flex here. Like but which pin in it? It's like,
Come on. In you go. Nope.
there's only one signal I know that's going through the flex connector, and that's Z1, the main clock.
I hate this panel thing. There it goes. All right. Yeah. All right. Yeah. The Data 620 also popped a fuse last time I powered it up.
Yeah, I actually, like, a while ago, did you get a replacement?
Yeah, I got replacement fuses. I haven't popped it in yet. Maybe we'll do that.
Yeah.
I'll let me.
A slow blow one?
Yeah. I mean, we still got some time before I'm about ready for bed. So let's. There's nothing more we can do on the Lytton tonight, I don't think.
Yeah.
Can't do anything without power, and we don't have power, and we won't have power until next week. Fortunately, I should have a new cap here by next week pretty easy.
Yeah. It's like our washing machine just blew their run cap, and now it's not spinning anymore.
Yeah.
Well, I mean, it is spinning, but I mean, the rest is not spinning.
Yeah, it's spinning, but it's not letting water in.
Yeah.
Exactly.
Dry cycles. Not again.
Come on. Line up. Line up for me.
I mean, I literally spent hours in that document. Everything in that machine spins, including the shift registers.
There we go.
Everything keeps up with the drum.
Oh my gosh, Lytton, you're killing me here.
I'll have to ask their design engineer why they didn't put like rollers or sliders on that.
Well, they put little. They did put sliders. They're just all broken after 70 years. Well, not
That
70.
design.
All right, so page 367.
What?
That's your whole flexible conductor list, Roy.
Give me a second. Which page?
367.
All right.
Yeah, that tells you from where they start to where they go.
And then if you want the rest of it, it's in the running sheets at the end of the manual. They don't
And
give you. They're not giving you
no.
exactly what you want. They're giving you enough to figure it out.
Now, I knew about that sheet, and I know about the end sheets, and I tried to use them, and I think I saw like one or two. I'm noting like at least 40 connectors here.
Yeah, I get what you're saying. It's basically a backplane though, so things are done in order.
Yeah, I know like each board is like just getting the same signal. They're not like playing around. A signal that is on one end is propagated everywhere, except for that one connector that has a break in the middle. But
Yeah, that's a weird connector.
yeah, and that's part of it. It's like I just went to the D board and I was just seeing, oh, there's so many lines. I'd have to trace them manually. But I mean, there are some images from the previous owner that Reese got me in touch with. I mean, the images. But we don't really have like big images of those boards.
We have the ones from Musagi though. I linked to them earlier.
You mean the actual like circuit boards?
Yeah, just like really good pictures of both sides to be able to trace them out.
Oh, well, why would you want to trace them out? We've got schematics.
Except for the card edge.
Well, we don't need to know about the card edge. We just need to know what connector goes where, right?
Yeah.
So we know the
Yeah.
name of a signal as it leaves a board, and we know the name of that signal as it goes into the next board.
Yeah, but I was just gonna try to get at the card edge which signal are going where. But,
That's way too much effort for very little gain.
Yeah, I mean, oddly enough, Reese did the whole list of all the ICs inside.
Yeah,
all
that's
their
pretty
locations.
wild.
That was nuts. Oh, by the way, the ones you're missing is 1D. They're all power amplifiers. They're in the list, except for one that I just assume is in 1D.
I'm not following you. What do you mean that I'm missing?
Oh no,
I'm missing something in my list. Just message me later.
yeah.
I love how all of the I/O for this computer is on that one Canon plug in the middle of the back.
Yeah. That's typewriter, tape reader, tape punch, all on that single Canon connector.
Yeah, they say it's a standard 27-pin 1966 connector. I mean, I think it's their own internal standard, but
No.
it's nice for them.
I think what they mean by standard is that it's a standard Canon plug. At that time, those Canon plugs were everywhere, man.
I mean, it's standard to them, and it's nice of them to say it's standard.
No, Canon connectors were used on all sorts of stuff.
Oh yeah.
Yeah, they were.
I mean,
they were as common as D subs are now.
Yeah, no, I mean the connector standard, but it's like to name it a standard 1966 27-pin interface.
It almost sounds like it's some kind of RS-232-like standard, but they don't mention which standard it is, as to pin 3 is this, pin 4 is that. But obviously the shell is standard, but what is there some standard pin out? So for some RS-674 or something, it'd be nice if we knew what that was.
Well, I assumed it's just like, oh, it's a standard Lytton plug, a Lytton connection. Good,
Yeah,
it works with Lytton devices.
I think there's a slight misunderstanding here about what they're referring to as standard, right?
Yeah.
Are they referring to the plug style as standard, or are they referring to the connections on the plug as standard?
Yeah, the paragraph is like very vague about that, which is the whole problem.
Check this.
Yeah, it's not really clear if it's the connector or the signaling that they're talking about.
They're not really even talking about. I mean, the paragraph states verbatim via the 1966 standard 27-wire interface. It's like,
Yeah. See, I read that as meaning like the plug is a standard Canon connector plug, but that could read as the standard Lytton interface. Which nobody knows what the heck that means.
I mean, they have the pin out, but...
All right, so $1 million question. Will it turn back on again? Yay. It was my... I put a 3 amp in it, but it wasn't a slow blow. That's the one that blew. And it originally had a slow blow in it.
Now we just have to watch slow and see if it blows.
Yeah, well now it's got a proper slow blow in it.
Which means it's gonna take some time to pop.
Or it shouldn't pop. I mean, you put a fast blow in a slow blow situation and it's gonna blow eventually. Right? The reason that they choose a slow blow, they choose slow blow for a reason, right?
Yeah.
Yeah, for inrush current.
Yeah.
But it still could pop. We hope it doesn't.
Well, yeah, I mean, if it does, then that says that there's something wrong with the power supply.
Yeah.
But the 3 amp fast blow popping, when it was supposed to be a slow blow, is not necessarily indicative of there being a problem in the power supply.
Yeah.
I mean, there could be a ton of other things going on that is the actual problem.
I had a tube audio amplifier from the mid '50s that was out of a Bell and Howell 16 millimeter projector, and it had to have a slow blow fuse because a fast blow fuse would just pop.
Yeah, and I'm surprised that the fast blow lasted as long as it did. It had maybe 20 power cycles on it before it went. But I knew that going into it. I was like, it's a fast blow and a slow blow slot. It's not going to do well.
Yeah. We're just not expecting a slow blow to just instantly pop.
Yeah, no. Well, that's the whole point of it being a slow blow, right? Is so it doesn't do an instant thing. Next week, I'll show you guys what I've got. This week, so this Saturday, or this Sunday, I guess, is for the UE homebrew. But coming up next week, here we go. The video is probably going to lag a little bit because there's the whole Twitch delay. But I'll set it here on the table, let the video get a little bit of focus here. That's what's coming up next week. Whenever the video catches up.
Commercial break in progress.
Oh, you got the switches.
Wait, is it giving you an ad?
Oh, sometimes.
No, it puts you in a small screen on the right, and then it tries to give me an ad in the main screen.
I swear I turned all of that off. I tried to, at least.
It's still yeah, it will still do it though. I think I've been lucky and haven't gotten it, but
Yeah,
I had the small pop-ups on the side, which are not that distracting, but
So when I get it on Shelby's stream, you get the ad. You can pop out the little version and just make it big. That's what I do whenever I get the ad on Shelby's stream.
It's not intrusive. It just pops up next to it.
Okay.
yeah.
I tried to turn all ads off, but I don't think you can turn them all the way off.
Yeah.
It's like the moment you hit affiliate, they turn ads on whether you want to or not.
Yeah, there's another little ad that pops up above the chat sometimes too. But again, it's small. It's muted. Doesn't get in the way. Neither of the ads play audio.
That's good.
This may be just a setting I have wrong, but I get the main screen shows commercial break in progress, and then the video, Usagi's video, goes to the little window above the chat. It like flips it on me.
Huh.
Yeah, that's how it does it when I watch Shelby's stream. But yeah, so if the ad break is over and you can see what's on the table.
Yeah. Are
Ooh.
you going to make a PCB for that? Or I mean, I tried to route one out, but it ended up like a foot wide.
Yeah, check that out. So what I'm going to do...
Is that your spare?
Yeah, that's one of the spare cards that I have.
Okay.
But Godfrey hooked me up with this connector because he was going to try and make a tester as well, and he never got around to it. But he had, this connector, and he had put some plates on it with a mount, so I can mount that to a chunk of wood. And then what I'm going to do for the switches here is I'm going to measure them out, and then mount, I don't know, a piece of aluminum or something, like a thin piece of aluminum in the mill, and have the mill go through and punch holes for each individual switch. So that way they're all perfectly spaced. And then once I have that, It's just a matter of like running wires and resistors, and then it gets real easy. And then we'll have our switches and lights tester for the Data 620.
Yeah,
So
it's gonna be a lot of wires.
yeah, but that, that doesn't bother me. Like
Yeah.
you should see the amount of like wires that I had to run on the UE1 just to get the two boards to connect to each other. So
Isn't there a project to build an Arduino-based tester for these?
Somebody was
No.
working on that. Somebody was working on an Arduino-based tester for VersaLogic, not specifically for these, but for VersaLogic in general.
Yeah.
But initially, I think the switches and lights tester is going to be the fastest way to handle it.
Yeah, and I mean the person that did a whole design, that's like over 300 components, and I mean I had a design with like 2 transistors and resistors, and that was still huge. He would have needed like multiple PCBs like stacked to get the density.
And it's just because there's so much variability in what each pin can do, because there's no. Oops.
I mean, I was just like putting either no power or negative power on each pin and being able to read them at the same time, which is enough for DTL, but that still took like a foot wide PCB. And it's like
it just takes a ton amount. Yeah. And so the switches and lights will get us to the point to where if we need to build a more specialized tester, we build it for the packs that we're unsure of specifically.
Yeah. The hilarious part is when I looked into the Lithium manual, because they need to convert to DTL, they had essentially my transistor circuit. So I was like, oh, somebody figured that one out.
Yeah. Yeah. So that reminds me, I need to actually order a 6-volt and a 12-volt power supply. I think I have a spare 6-volt, but I don't have a spare 12-volt. I've put it into use on the TMS homebrew. So sounds like I've got a Amazon order coming up here shortly with a Ferro-resonant AC capacitor and a couple of power supplies. Hopefully they can get that to me by like Monday. Amazon has been delivering on Sundays lately, which is insane.
You don't get same day?
Oh no, man, not even close.
They don't have drones for you?
The drone would run out of power before it got a third of the way here.
Yeah, we need ICBM delivery.
Yeah, although we might be getting pretty close to same day soonish, because about an hour from here, they're putting in a full Amazon distribution center. And it's like,
the scary thing is, for us, the Sunday stuff, and even some of the other overnight stuff, it just comes in, people in cars show up.
Yeah, for Sunday here, it's just like random people in their like personal cars, which is insane to me. And that none of them speak any English, which is great. It's hilarious.
Oh man.
Yeah, they'll show up and they'll be like, David? And I'm like, yeah, that's me. And they're like, no English, no English. I'm like, okay. Just give me my package, bro.
They don't even knock on the door here. They just leave it on the porch.
So sometimes they do. Sometimes they leave it on the porch. But if certain ones, they have to confirm our name for whatever reason. I don't know why. It depends, I think, on what you bought. I don't know. It's very strange.
Usually I just try to get it sent to a locker because I don't want them leaving it on the doorstep.
Yeah. Oh, Philip, yeah, the edge connector broke when I tried to pull the card out of it. It took the side edge piece with it. Not a big deal. All of the connectors are still intact, so we'll be all right. But it's not surprising. That stuff is super duper brittle. Yeah, so we need a new one of these.
You know what's cool? Soaking plastic parts in water to make them no longer brittle.
I didn't know you could do that.
It only works for nylon, which is not most of the stuff we use.
Okay.
But if you remember some of the old RC cars made by Team Associated, the RC10, RC12, RC8, stuff like that, had tons of machine nylon. That's how they did their whole business. And you just soak them in water. They absorb the water.
All right. Here we go. Since we're now clearly in the faffing about part of the stream, here's the cat. Say hi to the people, Sue. Kitty.
One brain cell and no tail.
Yeah. Yeah, he's got absolutely no tail. Just a tiny little nub here. And he's dumb as a box of rocks. He's also a big sweetheart. Just okay with everything. No, don't attack my microphone.
It's fuzzy.
Stop it. Stop it.
Since we're goofing around, I threw the that Easter egg image in the chat.
Oh, okay. Wait, what is the Easter egg? What is the actual Easter egg?
Well, I guess I'll give the people in Discord a chance to figure it out.
Okay, okay. Because I was like, yeah, it's a 6809. Like, I recognize that. And 60, but I don't understand. It was like a 68A09, and I don't know if that's significant or not.
No, it's nothing to do with the circuit. There's no bugs in the circuit. There's no missing parts. It's on the right side of the board. But I'll give people a couple of minutes, then I'll give it away.
Well, since we're
Bendix is looking lonely over there.
Yeah. I mean, we could turn it on. What do you want to do with it?
Oh no, I'm just you gotta put something over it, like I don't know, a picture of what was the guy that designed it?
Oh, Harry Husky?
Yeah.
What really needs to go over it, I'll aim the camera a little better here, is, so this is ultimately coming down to how long am I going to stay in this room. But what really needs to go over it is a hood that sits maybe about 6 inches above it, maybe 8 to 10 inches above it, that then just goes out the wall. So that way all of this hot air just goes outside.
Almost, I went on a vision quest, I call it, Googling all the ones I could find that were, in situ, in colleges and research labs. Almost everyone had a hood.
Yeah, because if you do that, like if there was a hood on that, I could probably run it all day with even with the underpowered AC that I have in here. Because it's just all the heat that's coming out of it just goes straight out.
Would you need a fan, an extractor fan, or it'll do its own convection?
So there's 4 fans on the doors that are pulling straight across the tubes. Then there's a vent here in the center that is a vent for the positive pressure that builds up due to the massive blower fan that's on the bottom. So there's a blower fan right on the bottom edge of this left side here that pulls in a bunch of cool air, blows it straight over the drum, and then all of that rises up through the center of the machine, through the guts, and vents out the top and the center here. Now, this one isn't going to be blowing out very hard because there's no fan up here to pull it out at speed. It's just going to kind of be convecting out of there, I guess. So an extraction fan might help. It would probably be a good idea just to keep it from, the hot air that's coming out of here, to make sure that that hot air is going through the extractor as opposed to, billowing around it or whatever. But that's like only really worth doing if I'm going to stay in this office for like more than 2 years. And I don't think I'm gonna. I think I'm gonna build the next office before that happens. Actually, I can kind of show you guys what I'm thinking about for the next office. This will be a first. Moving the camera outside here. Okay, yeah, you guys can kind of see what's going on here. So here in the garage, hopefully you can still hear me. I'm getting pretty far from the from the thing.
Oh, I hear you.
Directly above me is a giant metal beam that goes all the way across the roof. That metal beam is exactly at 20 feet from the back wall. So I'm planning on coming 4 feet forward from that. So that would be, about, say, like here-ish. And then putting a wall here all the way across. And everything from here back becomes the new office, the new studio. And so if the 709... I think somebody was trying to say something. You were breaking up.
Don't think so.
Anyway, okay. So if this office gets built, the IBM, if I can talk Bob into sending it down, the IBM 709 would go against that back wall, and it would probably fill out the entire back wall. But it's not very deep. So it would be like, 30 feet wide, 30 feet of computer wide, but it would only be about 5-6 feet deep. And then outside, on the other side of the wall, there would be a 400 amp diesel generator. So whenever we do want to power up the 709, we fire up the diesel generator and then bring the 709 up. And then, so it would be 709 against the back wall. This is kind of my plan. You guys can't see that edge of the room over there, but that's where the G15 would go and the mag tape. So it would be G15 and mag tape against that wall, 709 all along that wall, LGP 21 and a Data 620 and 1960 stuff along this wall. And then facing this way would be 1980s stuff. So like Centurion, PDP-11, that stuff.
Does this, you getting a 709?
So there is a greater than 0 chance that I could get a 709. It wouldn't be mine. It would be on loan, just like the G15. But it would be, it would be here, and we would work on it. I've talked with Bob about it. Bob has agreed that if I can get the space for it, then he'll ship it down.
Yeah, I didn't
tentatively.
I didn't even realize he had one that was in potentially repairable state.
Everything's potentially repairable if you've got enough time and money.
I guess.
It's pretty rough, but I mean, it's complete. So the only thing that really prevents me from repairing something is if it's incomplete. I'll repair anything if it's complete.
Yeah, I mean that's significantly. It's going to be significantly more complex to repair than the G15.
Oh yeah, no, it'll be like a 5-year plan.
Because yeah, I mean it's a full-on mainframe. Like
Yeah, no, it's a big boy, and it requires 240 volt, 250 amps, as best as we can tell.
I assume it requires 3-phase, or does it? Or
Yeah, 3-phase.
yeah,
Yeah.
I would think so.
Whoa! While I was outside, somebody gifted a bunch of subs.
Yeah.
Thank you, Particle Man Dot.
Do they have any software for it that hasn't been dumped yet, or that hasn't been like shared already?
Not a clue. I don't particularly know a whole lot about the system. I've just kind of seen it a little bit there. So my plan. So, all right, let's talk money. We got to talk money. Because building that office is not going to be cheap, right? Even though it's inside the garage, like you still have to build a wall, and you still have to build a massive roof, and then you have to build more walls on the inside with insulation. We have to wire the whole thing up with multiple circuits, and get lights in it and all of that stuff. And like, sure, I could do a lot of that myself, but it means that I would not have the ability to produce videos for a couple of months, which is, I would lose more money by doing it myself than I would by just paying somebody to do it and then continuing to work during the couple of months that it would take to do it. As a single person who's never done that before. So it's going to be like, I'm budgeting like 20 grand plus for this, not including the generator. Because that's not something that has to be immediate anyways. And potentially not including AC. So I haven't really thought about how to handle AC yet, but that's probably going to add another 5,000 to something. And like obviously I don't have 20 grand that I can just like throw down on this. Like 20 grand's a lot of money, like a whole lot of money. So I was thinking, like, I really don't want to do a GoFundMe or anything like that. I feel bad doing that kind of stuff. But when I deliver the G15, I am going to see the 709 in person, because I'm going to fly up to Maryland to help get the G15 installed, powered up, and fully running. And when that happens, I will go into the warehouse and I will, unbox as much of the 709 as I can and film a little bit with it and just say, like, there's a possibility that this 709 could come down to Texas and we could work on it. If you guys are interested in that, like, here's what it's going to take. It's a monetary thing. There's a monetary thing that's holding us back from doing this. And it's something that I really want to do. It's something that I really want to share with you guys. It would be like a 5-year project. So if this is something that you guys are interested in investing in, let me know, and we can go from there or something like that. Like, just gauge, like, if people are interested in donating to a GoFundMe to ensure that they get, 5 years of content out of seeing one of these things come up, or, maybe there's just somebody that's like, yeah, I'll donate some money because I want to see one of these machines get restored. So there could be, but I like the fact of the matter is that, like, the only thing that's keeping it from happening is about $20,000. If I had a spare 20 grand that I could just slap down on a contractor's desk today, there's a chance that machine could be here before the end of the year, So, yeah. Thor Drake, Bob has a System 360. They just picked one up from Germany. And supposedly it's a Ranwin parked System 360. But because it came from Germany, it's 50 cycle as opposed to 60 cycle here in the States. So they haven't really figured out how to power the thing up yet. But yeah, Bob does have a System 360, which is very cool.
So CERN's 709, they got a whole 1401 computer just to make input output faster.
Oh, geez.
Yeah, that was common with those. That's what they often did. They would use a 1401 to read all the punch cards onto a tape, and then they just run the 709 or the 700 or 7000 series machine from tape. That's quite like with the IBSys image. That's how it's set up to run. Well, they don't use a 409, but with like the emulated IBSys image, it's set up so that it runs jobs from tape instead of from cards.
So now you got to get a 1401.
Yeah, I'll just add that to the list. I mean, isn't the only functional 1401 in the world at CHM right now?
No, I think there's a few. I think there might be one or two others. I'm not sure about that.
I thought they had two, but as far as I know, those are the only ones that are running, at least reliably.
I thought there were maybe one or two others, but I guess maybe that is the only one.
What are you doing?
Considering how much Mark and the rest of that, and Tube Time and the rest of that crew do, anyone that is working, unless they have a large staff and actual IBMers helping them, won't be working for long.
Well, what you need is, you see, they made a portable 1401 in a truck trailer called the Datamobile in 1960. So you need one of those.
By the way, Roy Eltham got the Easter egg. It's Jenny's number, 867-5309, the wire colors.
Oh,
Jeez, that's deep. Okay.
I had noticed the colors. I was going, oh great, I'm not
There we
going to
go.
get this.
That Rue Moore person is pretty. They do some pretty crazy stuff, apparently.
That dude is a proper hacker. Like,
Yeah.
he builds some wild stuff.
So the core keeps the basic and the current basic program in memory.
Yep. Yeah, that's the Mandelbrot that we ran forever ago. I just you just fire it up for some reason, and I don't know why this is. It's consistently the same every time. But you turn it on, you hit stop reset, you examine address 2, hit start, and then you should just be able to hit escape, and it should work. And it doesn't. And so then you hit stop, reset, examine 2, hit start again, hit escape the second time, and then it works. Every single time I turn it on. I have no idea why it does that. Feel like maybe it's because I'm not, maybe I should be hitting continue or something. Let's try that. Let's go stop, reset, let me turn it off. If I turn it on, stop, reset, examine 2. What are you doing? Why are you running and unable to stop now? Well, that's awkward. You guys broke it.
The pot moved again.
I know, right?
For the IBM 1401s, there are 2 at the Computer History Museum in Mountain View. There's 1 at History at IBM in Berlingen, Germany, that is operational, and 1 at TechWorks in the UK. There's 4 of them.
Why can I not get it to halt anymore? It's like my stop reset button doesn't actually work.
Turn it off for 30 seconds and then try again.
Yeah, I guess so. That's weird.
Some things don't like being powered on and off too quickly.
Yeah, that's strange.
The Apple II Plus is pretty infamous for if you cycle the power switch fairly quickly, it'll just be gibberish on the screen.
It's never done that before. That's a new one. Oh, come on, you stupid key. I actually sprayed some of that, like, key lock special stuff in there. Didn't work. Didn't make a difference. There we go.
Got a lock ease.
Yeah. All right, there we go. All right. So if I do stop reset, and I examine it too, normally I go to start, but I wonder if I do continue. Nope. So now I got to do stop, reset, examine to again, and if I do a start and then hit escape, it goes. So I don't know why, but every single time it requires trying it once, stop, reset, try it again, and then it works perfectly the second time. Some weird quirk of the machine, I guess.
That's what, a 52-year-old computer?
Yep, she's getting up there in age. Oh, hey, the ADM3 went wonky.
I just realized when I said 52, I just mentioned my own age.
Yeah, it'll sit here. So sometimes when it's sitting here running the Mandelbrot, it'll halt midway through the Mandelbrot. And then if I hit continue, sometimes it'll halt again, sometimes it won't. Sometimes it'll sit there and do this for 3 hours. It did beep, and I don't know why the CRT is beeping. It shouldn't be beeping. I don't know. It mostly works. I don't know what to do with this machine though, man. Like, we've gotten to a point where it's pretty stable. So what do we do with it? You know, like every machine in this room has a purpose, right? Except for that one. The Centurion is all about big drives, right? 2 Hawks and a Phoenix plus a Finch inside of it. Centurion's all about big honking hard drives. PDP 1173 and the BOMIM, all about science, doing hardcore science. The 1144 with the FPS 100, learning about vector processors. The Lytton, and the Lytton is fun, but like, I guess it's a drum machine, which is kind of neat, but we have a better drum machine over there. So I'm not really sure what our ultimate goal with the Lytton is. The LGP21 is a memory disk. That makes it unique. And the Data 620 is a fully transistorized core memory machine, right? So the Nova feels like a miniaturized, modernized version of the Data 620. Like, I don't know. Like, I don't know, what purpose does the Nova serve?
Well, once you have the new room built, you need to get an X-ray spectrometer to hook up to it, right? Oh, wait.
Do you, my dear wizard, know the answer to my problem of 88-9? I feel like there's some backstory going on here, Teddy Tinkle, that I don't know. Yeah, sorry. What was that? So I was reading while you were talking.
I was just saying that once you have the new room built, you'll have room for the X-ray spectrometer to go with the Nova, right?
Yeah. If I could find an EDAX 700 series X-ray spectrometer, that would be perfect. God, that would be so cool.
Don't forget to get a Geiger counter with that.
But also, like, we're not sure what purpose the Nova served with the EDAX spectrometer. Because, like, there's no way, obviously, that the Nova can display any spectra. And it certainly didn't have enough horsepower to do, like, the vector math required for creating spectra. So, like, it might have just been the control computer for the spectrometer itself, you know, just controlling controlling what the spectrometer is doing.
Maybe storage? I mean, like controlling external storage?
Well, no, because it did directly connect to the spectrometer. I've got the cable for that.
Yeah, but I mean, if you run something through the spectrometer, you might want to store that data somewhere else.
Well, the thing is, it used burp, right? So maybe it was designed to have something that you could write your own programs to use the spectrometer for input for.
Yeah.
So,
But like, there's if it's anything like FTIR stuff, like you need something capable of doing the post-processing work, right? Yeah, Nova was a home computer though. Particle Man, Nova was not really a home computer. They were just a bit too expensive to be considered home computers. They're technically considered mini computers, but they were mostly used for business machines. Yeah, as with any computer, all they need to do is play Doom or download porn, and you already have a Doom computer. Boy, ASCII porn is rough.
Okay, X-ray spectroscopy is based on counting from the detector, so it's much less signal processing.
Okay, I didn't realize that.
So a lot of novas were also used in the typesetting industry. So when you had to actually take your graphics, and your text and everything else, and render it essentially to a plate, the nova would do that.
Okay.
So I don't know if you have any designs that are eventually doing printing.
Not really. I do really want to get into the different types of spectroscopy. Like, I really want to get my hands on an X-ray spectrometer. The likelihood of finding the appropriate EDAX 700 series for that machine is minuscule. But someday I do want to get an X-ray spectrometer. There's one on eBay that is taunting me. But it's from like 93, so it's a little new. It's also a lot of money, as they are wont to do. I kind of want to push. It's trying to think about, like, even if we get the new room, it's 300 square feet or whatever, or not 300 square feet. It's like 800 square feet or whatever it comes out to. But even then, that's not a warehouse. Like, 800 square feet is still pretty small. So we still have to be cognizant about total floor space and how we effectively use it. And the 709 is going to take up probably 150 square feet of that, maybe 200 square feet of that. Like, it's a sizable chunk of that. Like, the 709 would take up almost this entire room.
We just mentioned how the 1401 acted as a front end to the 709. Could the Nova play that part as a general purpose computer, but keeping the 709 happy?
It's a little too new for that.
Oddly, the G15 may be able to do that, because with a magnetic tape drive, if the formats are compatible.
Yeah. That's getting ahead of ourselves, but that could be cool. So if we have the 709 and we have the G15, like, those would be absolute positive musts. Have to stay in the room. Centurion's got to stay. That's a I'm taking that one to the grave with me. Everything else is pretty flexible. The BOMEM definitely has got to stay because we're doing lots of fun work with it. and I've got a pretty long roadmap with it that I want to figure out. We got to build a new case for the computer and monitor stand and all that stuff to make it fit a little better. And the 1144 with the FPS stuff, I'm really excited about the FPS. Like, I don't particularly care that much about the PDP-11 part of it. It's the FPS stuff that excites me. The LHP-21 is beautiful. Like, honestly, the Data 620 I'm kind of wishy-washy about, actually. Like, I actually like the LGP-21 better than the Data 620, and they're such a similar construction style that it feels almost redundant to have the both of them.
The LGP-21 looks straight out of like an early 60s science fiction movie.
Oh yeah, it's beautiful. It's like one of the most aesthetically pleasing computers I've ever seen. And when you have it reading tape and you can see the tape wheels spinning and you can see the bits twiddling on the CRT and the lights over here and the typewriter hammering, everything's like spaced out perfectly. It's gonna just be a spectacle to see this thing go.
Yeah.
The Data 620 is a big gray slab in the corner with a bunch of blinking lights on the front, which is cool, but not as cool as the LGB-21. And if push came to shove, and I could only keep one of them, I wouldn't even hesitate. It would be the LGB-21. But
Do you have the slide rule for that?
Yeah.
Sorry.
Yeah, the optimum address locator. Again, there's a bit of a
I just think that's the
Twitch
coolest
delay
thing.
here. Yeah. This guy is super awesome.
It's kind of the physical embodiment of the oh god, I can't think of it now. That the last real programmer text.
Mel K.
Thank you. Yes.
Yep. I'm going back in time on the chat here. Nathir Kassam, thanks. The place does look cool. I am very happy with how this room is turned out. It looks the balance of the room. I am very, very pleased with. Took a lot of work to get it there, though.
You do have a functionality black hole. The Lytton is right under the Nova.
Yeah, it's a bit of an issue. So the thing is like, speaking of the Lytton, you know, like how do we overcome, since we're the Lytton people are here, how do we overcome the problem of the fact that this is the only way we have to interact with this machine right now is the front panel, right? So we need a data terminal of some kind, and we need some way to get stored programs read into it and to store programs out. Now, I think we can kind of take a page out of the Nova's book here, because the Nova, when it originally came out, was meant to go with an ASR33, which is currently off camera. But somewhere along this particular Nova's life, it was upgraded to work with the Model 43 and this tape drive. Maybe. We don't particularly know, because the tape drive's at 1200 baud and the Model 43 can only do 300 baud. So it's a weird combination of the two. But the fact remains that it was upgraded to use a more modern terminal with a big tape drive. So let's use that thinking and say Model 43 with the Lytton definitely looks the part. And I was thinking this guy right here, the Tektran 817 tape drive. Obviously, I wouldn't sit it on top of the machine like that, but so the Tektran 817 data cassette drive with the Model 43 is now our I/O for the Lytton. And if we're talking about, if we're going to stay in this room, the only place then that can live is where the Nova lives. We put the Model 43 where the Nova is, we put the Tectran up where this other Tectran is, and then the Nova goes someplace else. If we move to the new room, obviously that's not a problem anymore because we've got a lot more space and I can build things a little better. So that's my thinking is Model 43 teletype, Tectran 817 data cassette, washing machine, all running together.
I mean, the difference is the Model 33 is like a standard current loop interface. I assume the Lytton's terminal is some weird proprietary thing rather than like a standard current loop or RS-232. Yeah, like the Nova wouldn't have been designed specifically for the Model 33. That was just like a very common terminal that supported current loop.
Yeah.
Or, so, I don't know, is it RS-232? I forget.
You're absolutely right. So the Nova was originally, I have the card up there. The basic I/O card was set up for 20 milliamp current loop, and they had it hooked up to an ASR33. And then when they upgraded it, they swapped out the current loop card for an RS-232 card and hooked it up to, you know, a more modern data terminal with the data cassette Tectran. The Lytton obviously can't do that. The Lytton has a proprietary typewriter and a proprietary paper tape reader and paper tape punch. I do not have those. And if the stipulation is that we have to use those, we might as well stop working on the Lytton because I'll never be able to find them.
You'll have to make some kind of...
Yeah, we got to come up with a translator.
Kind of adapter.
Yeah, we got to come up with a translator. The good news is that 300 baud is pretty slow, and that's what the Model 43 teletype runs at. And we just need to have a really good understanding of what the Lytton out and Lytton in is expecting. And then I'm all right with just building a full-on board that we just hang off the back that acts as like a translator between Lytton and RS-232.
Yeah.
Yeah.
My initial idea for that is because I know the Lytton interface is just basically 8-bit parallel out, 8-bit parallel in, and the Lytton is entirely in control of the speed. So that's how it's working internally.
Okay, but so when you say, so I haven't actually done any research on what the Lytton is expecting because all of my research has been, why did it explode? The 8-bit parallel out, 8-bit parallel in, let's just talk about the data terminal because I'm sure that it's also separate for the punch reader and tape, which also might be 8-bit in.
It uses it's just paralleling everything. Everything needs to read. It sends out an address. If you match the address, you listen in or you write out. If you don't match the address, you stay silent.
Yeah. So if the Lytton is sending something to the typewriter to type, it's going to send out 8 bits parallel with an address and presumably a hey, go do this signal or something like that, right? So we just need something that reads that 8 bits parallel, listens for the proper address, says, oh, that's me, grab the 8 bits off of that parallel data bus, pop them into a 1-byte register, and then, you know, get a UART to shuffle that out, right? And then in the reverse way, the user presses a key on the teletype, it gets 8-bit serial into a UART, the UART pops that over into a 1-byte register, and then kicks a flag off that says, hey, there's a byte waiting, right? Just like any other UART connection to an 8-bit bus, I'm imagining, at least.
It would be holding on to the data till the Lichen decides, okay, you can clear yourself out, going to something else. Because it's pretty much in control, it seems. The problem is all that control is done through Opus in software.
Okay, so if the user is typing, the Litten has to be in a state that it's willing to listen to what's typing. The concept of interrupts doesn't exist, I'm guessing.
Don't think so. Yeah.
And that simplifies it even further.
I mean, it reads punch tape at 50 characters per second. So you won't be saturating it with 300 baud.
Well, that's fine. We can go slow. Who cares?
Yeah.
Do we have to saturate it? Like, does it have to be at that speed?
I don't think so. It has like a busy flag. It's like, oh, my terminal is not ready to receive more characters. I'm gonna wait.
Yeah. So if we're not saturating it, we're not saturating it. No big deal.
Yeah.
We're not using the thing daily, so it can be slow.
As for standards, it's like one user manual talks about US ASCII for everything, and the other one describes a custom BCD that we now know every character in.
Okay. So really what we got to do is the next time that we spin this thing up, first of all, we got to try and figure out how to save Opus. That's incredibly important.
And we know we have a pretty good idea how to do so.
Okay.
Turns out, whatever's on the front panel is pretty much directing exactly which track it's going to use on the drum, even when it's idle.
Okay.
So essentially, if there's just like a fifth bit that's not getting like processed, but I mean, if we use a read memory command, it's going to set that bit, and we can now read a full track off of an internal register that's just streaming the track nonstop.
Okay.
So with the timing registers, Z1, Z2, and Z3, and that's streamed in, if we have that data set just piped into your scope, we should have full Opus.
Okay.
In 2 reads.
Then we just got to decipher it from the scope out.
Yeah, and we have the instruction set, and Reese and I have been working a bit on that instruction set. I've also made a program that streams out the entire memory content through that Canon connector. But that's a bit useless because you have nothing to connect it to.
Well, we could connect the scope to connect to the Canon connector as well, right?
Yeah, but now it would be 8 bits parallel. You could read it before it becomes parallel. I've put that in my mind too. But it's like, while you're at it, just read it off the drum.
Yeah. Pistoliches, I don't know how to say your name, but thank you for the Prime Gaming subscription. Heck yeah. That's awesome. Can the Nova be a bridge of some sort? Completely naive state. Yeah, so that was another thought I had, Particle Man, and Philip, was instead of the Model 43, use the Nova. But then that feels like kind of weird because now your bridge is more powerful than the actual machine that you're bridging to.
By a lot.
Yeah, by a not insubstantial amount.
That's like I had an idea that maybe we should have an intermediate board that, while we don't do the final design, just have a microcontroller interface with the Litten like directly. So
yeah, initially that's what we're gonna do. We're gonna start dumb easy with like a microcontroller and make sure that we understand how we can interface with the Litten. And then we'll take that knowledge and break it down into more period correct, mid-1970s period correct stuff. because there were UARTs and ROMs and whatnot available in the mid 1970s. So
Yeah, and Reese told me about a chip that does UART to two parallel ports and read in, read out separately. Old what was it? Old disc company, I think, or something like that did it. So it's like, oh, cool. But I'm thinking about the address problem is going to be a bit more serious than I think.
Solder and Code, thank you for the Prime Gaming sub. I don't know what a founder means, but I'm glad you're a founder. That's probably some
It
Twitch
said-
stuff that I should learn.
That's me. I don't know. It said I got a founder badge for subscribing.
Oh, that's
with my
you.
Prime thing. Yep, that's me.
Everybody's got 4 usernames, and I'm never going to remember who's who. But yes, thank you. What you're a founder now. Thank you. I don't know what that means.
I don't know what it means either.
With our powers combined, we still don't know.
Well, I mean, weren't you like the first one to sub?
But it said I got the badge for subscribing. So maybe it's the first 100 subscribers. I don't know.
Founder badge. Particle Man Dot is one of the first Prime or paid subscribers of Zagi Electric's channels. All right.
Oh, you got a hype train going.
There's all sorts of stuff going on. We did it. Thanks for all the support. 10 out of 10. I don't know what that means. There is the beginning of a hype train going.
What's a hype train?
A hype train, it's hard to explain. Because I don't particularly know either. I know it's good. It's like if multiple people are subbing and gifting, it's a way to inspire people to continue doing so rapidly, because you get, with higher levels of hype train, you unlock more things.
Yeah, I mean, it's exploiting FOMO, fear of missing out. It's like, oh,
yeah, it's a
people
little
are already
exploitative.
subscribing. I need to
That's
send
what Twitch
bits.
exists for.
I need to send more bits because somebody sent more bits than me. It's like,
Yeah,
oh,
the scam train. Yeah, it is a little exploitative, but also it can be kind of fun, man. Like when I was at Shelby's, we got a pretty big hype train going, and that was like incredibly exciting. It was really kind of fun.
And that's how they get you.
Yep, Philip, it is getting difficult to brain here as well.
I mean, I'm an hour ahead. That doesn't help.
Oh, are you on East Coast?
Yep.
It's like 2:30 there. Good Lord.
Yeah,
Yep.
me too. It's early.
It's early. It's definitely early. I've started my day at 2:30 in the morning before. Usually when I got to drive somebody to the airport, but
Oh, yeah.
yeah, because it's like, you know, if Mickey has an international flight that leaves at 7 a.m., I got to get her to the airport at 5 a.m., which means I got to leave here at just before 3 a.m., which means I'm out of bed at 2:30 a.m. So, like, yeah, I've started my day at that time before.
When I had to do that type of thing, and was doing China, I was making them spend the $50, get me a car.
Yeah, there's not a car that can go from here to the airport.
Yeah, no, I mean Long Island to JFK, it wasn't terrible, but for you to go there to the airport, I'm sure it would be a much more expensive trip.
Yeah, I think it's a little over 100 miles to DFW from here. It's not.
I used to stand gate guard in the Navy, and midnight to 8 was like one of my favorites because it was quiet.
Yep. God, these bone conduction earphones are insane. You can't even see them on my head, and I can like actually hear the room. It's crazy. You guys are in my brain when you talk.
Which ones did you get?
I got the Shocks.
Yes, yeah, the ones that go around the back of your head.
Yeah.
They are nice. I have those, and I have the other ones that it just clips over your ears with the same brand. Those don't bone conduct, but they're still good that you can hear the room.
Yeah, these are fantastic unless somebody's got a really bassy voice, like Reese Weatherly. His voice is so bassy, these things vibrate, and then I can't hear.
Yes, I've noticed that.
The problem is, I don't think it's his microphone. I mean, he's on the other side of the planet right now.
Yeah.
I mean,
yeah, but yeah, it could be any number of factors. All right. Yeah, it's 1:30. It's time to spin it down. I'm going to order a new one of these. Next weekend, we're going to put this guy in. And then we're going to fire the machine back up. And hopefully all of our DC rails come back. I am pretty confident that this AC cap is what has gone bad. It doesn't measure as a cap anymore. And everything tracks with the ferro-resonant side not working. So next week, we're going to get the Lytton going. And then hopefully we'll try to save Opus. And so that gives us one more week to figure out the best way to save Opus. Opus being the operating system. And as we just discussed, the road for the Lytton is going to be long because we got to figure out how to do all sorts of translation stuff. So that's it for me, Twitch. Thank you guys for joining. We'll see you next week.